Well, good morning and good afternoon to all of you joining in today. I'm Ryan Marlowe and we'll be moderating today's UAS for Bridge Inspection Peer Exchange with my co-host, Jesse Escamilla. Alaska has seen massive growth and adoption over the last few years with the integration of remote sensing technologies into our workflows with unmanned aircraft. With over 200 remote pilots and 100 UAS platforms across the state, our UAS program has accomplished over 2,000 flight missions, ranging from corridor mapping with beyond visual line of sight, operations over people using ballistic parachutes, airport runway and approach surface inspections and mapping, and starting today with integration into Alaska DOT's bridge inspection program. Today, you'll hear from industry experts across the nation and how they are augmenting their bridge inspection workflows with a range of technologies. Our peer exchange format will give each presenter about 20 minutes for their presentation, leaving room at the end of each session for questions from the audience or panelists. Please be sure to use the question and answer box and not the chat box so we can make sure we get all your questions answered. If you do have any issues, we do have a production team standing by that will be able to assist you. Just a reminder, FHWA and Alaska DOT do not endorse any of the products or software or services mentioned during today's presentation. I'd like to thank Federal Highways Administration for making this event possible. And with that, introduce Peter Forsling, who is the Bridge, Research, and Marine Highway Engineer for FHWA's Alaska Division Office. Peter?
Hello, welcome to our UAS Bridge Inspection Peer Exchange and a hearty virtual welcome to Alaska, where we hope to be able to see you all in person soon. Thank you for participating. I hope that each of you have come ready to ask questions. I anticipate that you're ready to share answers, and I invite you to adopt innovations revealed in these exchanges. I'd like to kick things off by proposing some questions for you to consider, which we may not answer today, but might help us develop our UAS capabilities in Alaska. Any answers are, of course, very welcome, but even additional questions may be helpful. Some general questions I might suggest then. First, how well do we need to understand the capabilities of UAS systems and their applications before we explore an overall DOT architecture and budget? Second, do our senior DOT managers understand the business case for UAS use? And if not, how do we use proper channels to build and promote that case? Third, would highway-oriented UAS capabilities grow more evenly or rapidly if we used a capability maturity model approach? If so, what would that look like for UAS capabilities? Fourth, what balance of ease of use, system sophistication, and cost gives us a good operating zone for using artificial intelligence processing to flag inspection items in our UAS generated data? Fifth and last, we learn a great deal from each other in peer exchanges like these. How far down the learning curve would it be beneficial to establish a more formal user group? Should a user group be focused more on the UAS technologies or more on the UAS applications? So today we get to explore many aspects of the UAS systems as applied to bridge inspection. And I want to thank our host, the Alaska DOT&PF, for setting up this opportunity. And I look forward to hearing what all our speakers have to say. Thank you.
Hi, thanks, Pete. I appreciate your kind words. My name is Jesse Escamilla. I'm with the Alaska DOT Department of Transportation and Ryan's co-host. I serve as a bridge engineer for the state of Alaska. I've been here for about 7 years now. I started off my career as an intern in 2004, sorry. And I worked on the private side for a number of years before coming back in 2014. I am considered a bridge engineer for the state of Alaska as a technical engineer, leading multiple design projects, including new structures, rehabilitations, and retrofits. During the summer months, I turned my inspector hat on and am a team leader for routines and fracture critical inspections. Additionally, I lead the high mast tower management program for the state, and I'm currently tasked with implementing a UAS program with our inspections. So I'd like to move forward and share a screen and just give you guys a background about bridge inspection in Alaska and just our office in general. So let's see. So yeah, and thank you all for attending. It's been nice that we've had the ability to reach out nationwide. Ryan and I have been talking about doing this presentation for some time. Initially, I think it was supposed to be an in-person event, and that would have been a tough sell for a lot of you to talk your superiors to let you fly to Alaska for a 3-hour drone seminar. So as mentioned, I've been tasked with implementing UAS programs, inspections with our current bridge inspections. And some of you all probably have the same logistical problems that I had of trying to figure out how to implement it, how to properly use it in a good workflow, the logistics of incorporating it in. And this peer exchange seemed like an excellent way to learn from what others have sort of done prior to. Since I'm clearly not an expert in UAS or inspections in that sense, utilizing them, I'd like to give you all a background of Alaska DOT bridge section and how we came to the conclusion to start implementing UAS. No presentation is complete from Alaska without a scale overlaid onto the United States to show our size and what we have to deal with logistically. But what I'd like to point out is that our geographic sort of central hubs of Anchorage, Fairbanks, and Juneau are very, very far apart. And more critically to us as the bridge section, we serve in
I'm sorry to interrupt. Your screen is not showing.
Oh, I do apologize.
That's okay.
Thanks. Okay, so back to the scale of Alaska. So here you can see Juneau and the distance in proximity to where our office is in relation to the rest of our state and sort of our vast geographic area we have to cover. We serve in a statewide function, our bridge design headquarters, so we don't have regions, so we're all based out of Juneau. Our staff of about 20 engineers, we are pretty diversified. We're broken into a couple of sections, 2 design squads, a bridge management squad, and a hydraulic squad. And although we are in squads in a sense, we do a lot of work sharing. For instance, our designers will also perform load ratings, inspections, and bridge management will also do designs. We have a lot of well-trained engineers in that sense. We consider ourselves a production office. We design roughly 80% of all bridges in Alaska, whether they're new bridges, rehabilitations, or preventative maintenance. 80% of those get pumped out of our office in the state. So in the summer months, we do turn our inspection hats on. These are our routine inspection team leaders, and that goes all the way up to the top to our squad leaders and our chief bridge engineer. Each of us will have at least one routine inspection trip, which is pretty uncommon, I think, for chief bridge engineers to be out with a hammer banging on concrete bridges. So it's something that we all take pride in what we do. In fact, we perform 100% of all routine bridge inspections in the state. It's handled through our office. And then segueing into fracture criticals, we have a lower number of team leaders, although we're all the routine inspection leaders are capable of doing it. For logistical reasons, we reduce those numbers. And then performing 90% of those as well in-house. We limit the rope access and specialty climbing ones, but anything that we can access with a lift or under bridge inspection truck is what we typically will inspect. So let's look at our bridge inventory and our highway system. We don't have a lot of highway that covers a lot of our state, as you can imagine. A lot of it is non-redundant, or it's critical if we did, through an extreme event, lose a bridge, we would have detours that could be hundreds of miles or potentially there would be no alternate route. Like on the Dalton Highway, there is only one road that goes in or out. So our infrastructure is critical in that sense. We have a little over 1,000 bridges in total that cover our state. You can see the bulk of them follow the highway system, but we do have many that are dotted along Western Alaska, out the Aleutian chain, and in communities in the southeast. And they're all guaranteed to be as picturesque as the one that you see here on the Seward Highway. We have a little over 100 fracture critical bridges around the state. And I'm starting to sort of key into bridges that may be used for our future drone program. We have a 326, last I checked, of bridges that I would say are in the potential to be looked at. Bridges that are 3-span plus that go over water that have limited access. We have 6 signature structures that maybe have main spans greater than 400 feet, and 18 multi-span trusses in our inventory. So why are we looking at including unmanned aircraft into our inspections? Well, to supplement our routines, our in-depths, low waters, and fracture criticals. Obviously, they're not going to replace hands-on inspection, but we do look at other elements when we're in our trucks. So in that sense, maybe we can expedite our inspection trips. We're one of few states that I know of that on our routine inspections, we don't typically lower underbridge inspection trucks. We perform a routine inspections from the ground level with binoculars and spotting scopes to assess spans that we don't have access to, using engineering judgment and just sort of what we can see visually. If we do have to see more, we will then flag it and get a special inspection to come through at some later point. But you can imagine this can get complex on some of our longer span trusses or deck trusses where access is definitely very limited to just this slope that leads up to the first span. Another reason we're looking at including aircraft is inspector safety. That affects me greatly. As you all know, being on a bridge deck with traffic adjacent to you, it's not great. The more time I can spend off the bridge deck with variables that we can't control, the better. So if we can inspect certain elements and not be on the bridge deck, then I think that's a win-win. Obviously, there's advancements in technology. Drone technology has increased rapidly. As I'm not talking technology when it comes to chain dragging, it's definitely tried and true. However, and this plays into safety as well. Obviously, you're on a bridge deck to do something like this, requiring you to chalk out and estimate areas of delaminations and spalls. But through thermal technology, we can now use drones with FLIR cameras to take pictures and images, videos of areas such as this. Whether it's full AI autonomous and you're using it to calculate the areas internally, or you're taking pictures and going into AutoCAD or MicroStation and measuring areas, there's obviously ways that we can do this alternatively. And we have had a slew of emergency inspections as of recently. I am going to make some changes in my settings for 1 second I do have a video coming up. So in 2018, we had a magnitude 7.1 earthquake that struck in Anchorage. Our office was deployed to, and we performed inspections on a little over 300 bridges that were affected by this, roughly 1/3 of our inventory. Luckily, there was only minor structural bridge damage, which is why this slide shows a roadway photo. But aside from obviously taking really cool aerial photos, what may have we potentially had to do, or what may we do with UAS if needed? Well, the bulk of our bridge inventory, our modern bridges, use steel pipe pile, steel pipe piles that are encased or that are filled with concrete filled steel pipe piles. Sorry, hard to get that out. And we do that because they're really ductile. They allow a lot of movement in seismic situations. Imagine if this bridge was pushed on transversely left and right. We get that ductility, great, but what we do at the top is we stop our piles short from being embedded into the piers. As you can kind of see in this photo, that top, what is a 3-inch gap. We essentially build in a fuse, a weak link. It's a designed point of failure for us for earthquakes. And luckily, the earthquake event that happened in 2018 didn't hinge any of these locations. But if need be, we may have had to have gotten up and looked at the severity of the damage. You can imagine this is a hard thing to do on steep slopes in ice and snow and dark. In future earthquakes with UAS inventory, this may prove to be easier to accomplish and safely as well from the ground level away from the bridge. We've also had a number of bridge strikes as of recently. Pay attention to the roadway down here as you'll see a bridge strike coming from a webcam footage. So this was a dump truck that came in with its bed up, slamming into the side of the bridge. This is Dowling Road over the Seward Highway in Anchorage, and I'll play it one more time if you missed it. An impressive impact with that. We had another event that happened on Artillery Road over the Parks Highway. This is just north of Anchorage in Eagle River, where a truck carrying a Connex box got sardine canned and the top ripped off, damaging the girder. In both instances, the girders had to be replaced. Traffic was diverted because of unstable girder that could potentially have collapsed. So, for inspecting, anything that we can do to not be directly underneath what is unstable is an added benefit to us. So one more example of a bridge strike. This is a tall bridge. It's the Juneau-Douglas Bridge in Juneau, connecting Juneau on the near end and Douglas on the far end. And you're probably thinking, well, this is a tall bridge over water. What could possibly hit this, right? Well, I give you the ingenuity that is crane on top of barge pushed by a tug. Yeah, that actually happened. And what's great is cell phone video coverage that pops up on Facebook is how we find out about events such as this. And this was an excellent study for UAS inspecting because we had just started the talk about implementing these into our inspection workflow. And this was while COVID was going on. This is actually one of the first times I saw coworkers in some time since we quarantined. So I was tasked the next day with investigating the damage and assessing it in a detailed manner. And our typical way with binoculars and spotting scopes, you can tell it's hard to get up and see where the damage location was, even at low tide. We utilized our trade secret trick of GoPro on a stick to access and visually see the damage that you can sort of see at the bottom down here. But even then, our first attempt was, we could see the damage, but it wasn't great. The GoPro was too wide angle of an image from this long overhang to actually get the visual. It actually required a trip to Home Depot to go and get some rigid metal conduit to fashion into an L. So a vertical leg and an elbow and a horizontal leg, and then attaching the GoPro. So we've updated that refined technology, but it did give us the visual. However, had we have had an aircraft in our inventory, what took 4 hours would have been a quick sort of deploy, take some images, and we're done. Because all I was after was an image to get like this that I could quantify the damage, ensure there was no bars exposed, no pre-stressing strands or ducts that were ruptured. We also have a good amount of potential disasters of floods, slides, or tsunamis. This is the Low River in Keystone Canyon along the Richardson Highway near Valdez. The river crisscrosses the highway a couple of times, and in high rain events, we can get water that overtops, potentially scouring out the bridge and approach roadway. So being able to visualize these from a safe distance is is something that we'd really like to have in our inventory. So where are we at in our UAS program? Well, in April of 2020, so just recently, we were awarded a $100,000 stick grant. And for our little bridge office that we maintain, that's enough to kickstart us. We've procured 2 Skydio platforms that I envision to be our workhorses. They're going to be, I think, the ones that do the bulk of our flying for day-to-day inspections. And we also have 1 DJI Matrice 300 with optical zoom and thermal sensors and a spotlight for specialty inspections or nighttime inspections if need be. 3 of our inspectors who go on our inspection trips will shortly take their Part 107 exam. Mine will be next week, is what I have planned, and 2 others very shortly. And this summer in 2021, we're going to start implementing them on select bridges that we're assigned to. Like that list I showed earlier, possibly longer span routine inspections or multi-span routines or fracture critical aids. Again, not replacing the hands-on experience, but the hands-on inspecting, but serving as a supplement to other items that we inspect. So with that, that's all I have. And I'd like to segue into our speakers. As Ryan mentioned earlier, you have a Q&A box. We ask that you use that and populate your questions as the presenters are giving their presentations, so they're queued up, so we don't have time lost as we're waiting for questions to populate between presenters. That'd be appreciated.
I do have one question from the audience from Michael. The question is, what was shown with infrared photo on the bridge deck?
Oh, you know what? I don't know, actually. That was a Google stock photo, as we have not yet implemented with UAS, so that was not my image.
Most likely delamination, though, with the thermal loading.
Correct. And I will stop my share. So with that, let's go to our real presenters who are experts in this field. So with Ohio DOT, we have Mike Brokaw. He is a licensed professional engineer with 17 years of bridge inspection experience, graduating from Ohio Northern University with a Bachelor's of Science in Civil Engineering. Upon graduation, he spent 5 years with Burgess & Nyepel, a consulting firm in Columbus, and the last 12 years at the Ohio Department of Transportation Central Office as Ohio's Bridge Inspection Program Manager. So with that, Michael, we welcome you.
Thanks, Jesse. All right, can you hear me now?
We can.
Wonderful. I was wondering, Jesse, could you send 1 snow-capped mountain to Ohio? We just want 1 of those. Those are incredible. What I'd like to do is share with you our experience in Ohio. It's really not much different from what's happening in Alaska. We might be a few months in front of it. So hopefully from my presentation, you can copy and steal whatever you like, and we'll go from there. So thanks for the intro. Here's the outline on the left. You can read the outline as I show the video. I want to show kind of where we started with using drones and bridge inspection is on our major structures, our signature structures, big cable stays, big cast in place, post-tensioned superstructures, the difficult to reach superstructures. And it didn't take long for us to see value just in the major bridges. So if I show the video on the top, you can see the spall up here on the top of this tower. When we would inspect this bridge, we would rappel and climb once every 5 years, and in the off years, we'd come out of this hatch and just sight around on top of the tower. This spall was impossible to see from the hatch, and it was impossible to see from the ground. So it didn't take long for us to start seeing value in using the drone in bridge inspection as a supplement to our in-depth, supplement to our fracture critical. And where we're trying to build this is to supplement our routine. We're trying to knit it into the fabric of normal daily operations. So My outline here starts with the major bridges and then goes to how we're using drones with reactive, reacting to problems. And we'd like to get into the more proactive use of drones. We've seen some value in project scoping, bridge maintenance, bridge construction. We've seen some value in some cool stuff. I got some photos, but I'd like to eventually get down to this policy and procedure, kind of speaking to other DOTs and implementing this and how we did it, how we're doing it in Ohio. We're not really crossing the finish line yet. We might be a little unique, a little different in the fact that the state of Ohio has a UAS center. We have a center that has a bunch of drones, has a handful of pilots, and they're looking for places to implement drones. And out of the 1,000+ hours of drone operations last year, a small number of those hours were doing bridge inspection. Most of it is doing survey, construction monitoring, crime scene monitoring, everything within the state, within all the state agencies. And so you can see the evolution of the timeline with the UAS Center starting with the earlier drone technology in 2012 and kind of ramping up when the Part 107 was released. You can see the ramp up into drone usage. And I would say in the bridge inspection world, we are, once the Skydio 2s came out, we just used them. We like the Skydio 2s. We don't get paid to say that. It's just a drone that is working for us. And we expect the same type of curve with bridge inspection to take off with the Skydio 2s. So as a background for Ohio bridges, we have a bunch of bridges. We are a home rule state. That means the more local, more regional you get, the more authority that local entity has. So we have different jurisdictions. We have the state highways and interstates, and then we have turnpike, our publicly elected county engineers, our professional engineers, our mayors. So you can see how many cities we have with bridges, how many bridges. We have 45,000 structures that are considered bridges in the state of Ohio. Not all of those meet the definition of an NBIS structure. If you're looking for the bridges that meet the NBIS structure, it's this number 28,596. So we have a lot of bridges, but let me drill down just for the state structures. We have 12 districts. And we deem the bridge engineer of the district the responsible person, the responsible charge. The bridge inspection happens out of their shop. And there's 14,552 state bridges. We look at boiling it down even more. We have an underbridge inspection truck. We have 2 underbridge inspection trucks. That's an operation that's centralized. And we very simply divide the state in half. We have a northern U-bit and a southern U-bit. We call them snoopers, but they're technically Aspen aerials. And they do 400 bridges a year. And that's the process that we're trying to knit that into our normal supplement to the snooper operation. So far, if we look at the operations, we're kind of, maybe if you're in the infancy, we're the toddler. We're just kind of getting used to where drones might fit. What are some of the obstacles? Probably we're split 50-50 as a department if they're good or bad. There's a lot of people that think they're a waste of time. They're just a pretty picture, and there's others of us that are seeing real value in using them in bridge inspections. So the year 2018, we had 45 bridge inspection missions, and last year we had 51 bridge inspection missions. We anticipate in 2021 to have more than 51 bridge inspection missions. We've already scheduled proactively about that many, and then we'll probably get 20 to 30 reactive bridge inspection missions. So we'll be closer to 100 in 2021 as we start ramping up. We started using drones and bridge inspection for our major structures, and this is one of our big cable stays in Toledo. And where we see benefit right off the bat is, if we're going to rappel this tower and we're going to rappel out the cable stays, using a flying camera is a much safer way to do that. And we can get similar video. We might not be able to get a close-up of a crack indication or something very minute, but this could be the first envelope. A drone inspection could be the first envelope of, and drone pilots get distracted. This apparently the pilot was into boats. Okay, back on track now. You can see how dangerous this climbing can be. So We anticipate on using the drone instead of climbing every 5 years, perhaps using the drone to offset climbing to a 10-year cycle. More major bridge stuff. This is a drone of our snooper. We have ongoing research with the University of Cincinnati on this structure in particular. It's the Jeremiah Morrow Bridge near Cincinnati. We want to get a set flight path that takes video or photo of every single square foot of this bridge, and it will automatically find crack width, crack length, and determine if there's growth, if there's change over time. So we have ongoing research there with UC, and that's happening. And so that was kind of the major bridges. That's where we started with drones. Where we moved then into using drones more often as the reactive. We fortunately have 4 team leaders in our central office that run and manage our underbridge inspection truck operations. And again, I said we do about 400 bridges every year. We schedule them now. We schedule them ahead of time, and then we go implement the schedule. Well, when we show up to a bridge, often there's construction, or there's bad weather, or there's COVID. A global pandemic can take out a whole garage of traffic control. So when that happens, usually we just do the inspections from the ground. But in 2020, we were able to, instead of using the snooper, we were able to use the U-bit or use the drone and basically offset the snooper days. So we're reacting to our normal operation and finding value there with 39 inspections. Another value we found, we have some structures like this interstate ramp with the blue dashed line that is on such a super elevation and has such high ADT that you can't close it. You just can't close it for one, and you can't put a snooper on it for 2. No matter how hard we tried, we just could not snooper this bridge. So using the drone was really the only way we could get close up and look for those out of plane bending cracks, close up inspection for crushing. Little closer than from the ground. Our general rule of thumb is if you can't get within 35 foot, you should probably put it on the snooper list, and you should schedule it every year, every 5 years, somewhere in between. But we're seeing that we could do that with the drone. We could use the same policy with the drone. 35-foot sight distance could be a drone as well. So another success story we had, Kentucky found some indications, some fatigue cracks on their approach spans, and we wanted to look at the same detail on the Ohio approach spans, but we could not get a snooper in there because of construction. It was interstate, and fortunately we were able to bring the drone in, and it was able to zoom into those cope holes and do an inspection for fatigue cracks. We could get close enough to inspect for fatigue cracks. So another win for the drone. Once we had the three wins I just shared with you, I was convinced. There was a spot for drones. So once we did that, we started asking inspectors if they'd be interested in being pilots. We have 2 central office employees that are pilots that run our snooper operation. Another example of an interstate bridge that was canceled is this one. And notice that there's a number of interior spans that you simply can't get into from the ground. Using the drone was very, very helpful because the alternative is just kind of a sorry inspection. This drone was, here's the pilots over here. The drone was able to get to this seated hinge all the way, a number of spans away from the bank and do an up close inspection to look for fatigue cracks in that seated hinge. So a benefit there. Another place we reacted was we got a phone call from our permits office. Permits said, hey, we had a super load drive on this bridge. They were off permit, and they said they heard a popping sound. Can you send the snooper truck and do an inspection for fatigue cracks, for buckling, for bearing movement? And we had the question, well, if a super load caused popping, our snooper truck's pretty heavy. It's a permit vehicle. It doesn't make sense to put a heavy snooper truck on a bridge that might be buckled. So it's another win for the drone. We were able to fly the drone in and around, even in between the beams up close to the deck, to look for fatigue cracks on those fatigue prone details and inspect all the bearings. There weren't any fatigue cracks or buckling on the bridge. Another win. We're trying to be proactive with the drones, so we added a drone inventory field, yes or no, with a frequency and an inspection date. We're attempting to be proactive. We're not quite there yet. Some places we are currently proactive is with known issues. The snooper has found issues, corrosion holes like this. Instead of using the snooper every year, we can use the snooper every 3rd year or every 5th year. And in the intermediate years, we can fly the drone up to a known issue and see if there's any change. So that's one way we're being proactive. Another way, similar with the section loss I just showed on the last slide, is fatigue cracking. We have a fatigue crack here, or an out-of-plane bending crack, that we found during a normal inspection with the snooper. We can follow up to that known problem area with the drone and see if there's any change, any growth. So we're trying to be more proactive. In 2019 and 2020, we started seeing a lot of benefit with project scoping. You can see the photo. A huge helpful thing for drones is that they can give us a big perspective of a long bridge or a big deck or a big wearing surface where we're trying to decide if we should replace the deck or do an overlay. Stitching images together and putting, after chain dragging and highlighting the squares with, highlighting the laminations with spray paint, we can then calculate very quickly the total overlay or total deck replacement needed. We found with project scoping benefit, the drone will go up and do photogrammetry and determine how long the approach slab bumps are and determine what type of project we should do for big, long projects. We can also get close on bearings, replace or rehab, and we can look at structural steel section loss and or cracking for scoping. I'm going to show a video. This is Dan, one of the 2 bridge snooper operators, team leaders that is flying the Skydio 2. Notice he's holding the Skydio, he's turning it on, and he's flying it up to the pier. And what he wants to see, we're going to be pretty close to traffic here. Some of you might cringe, but what we're looking for is Dan was charged with looking at the forward and rear face of each bearing. I think there was 6 or 7 beams and there was 6 or 7 piers. And he flew the Skydio 2 on the forward face and took a photo of every single bearing. There it is. And it didn't move. You really can't crash these things. And then he did a photo on the rear face of every bearing. Super cold this day. This was just a couple weeks ago. And it just took 2 batteries to do it. Yes, we could have done a ladder. We couldn't have done a bucket truck, and we didn't want to do a snooper truck. This was the best method for doing it. And I think he was done in less than 30 minutes taking a photo, and then processing the photos took another hour and a half or so, and organizing the photos. But it gave us what we wanted. Here's a photo of the joystick and the very tiny micro SD card. The Skydio 2 is not terribly expensive, so our inspectors are not overly nervous about losing them. We have lost a very expensive drone before, and it kind of made everyone a little bit touchy. The Skydio 2s are $1,500, $1,600, so if we drop them and lose them, it's not a huge terrible loss. And yes, it can get into tight spots, and you really can't crash them. Here's a picture of the bearing we were looking for on the left, and there's a picture of the joystick and the that's an iPhone. You download the Skydio app on the iPhone and use it as your imagery as you fly around, take photos. Infrared, I'm not a big fan of infrared yet. We haven't seen a huge benefit. Where we have seen benefit is where we close down traffic and spray paint the wearing surface, and then do a drone imagery on top and measure them all together. So you can see some of the spray paint squares in the left-hand image. And then infrared, not a big fan of infrared on or infrared under. It's not really telling me anything yet that you can't see visually. So you can see a lot of the issues visually. We used a drone to make a 3D imagery of the super span culvert, corrugated metal pipe. How much corrosion do we have through the pipe? And that was kind of cool. I'll skip through some of this, but we have found benefit where we're looking for workmanship issues. Getting to the policy and procedures, yes, we work under Part 107, Rules of Operation from the FAA, and we have just a handful of ODOT policies and procedures I have listed there. Data usage guidelines, being in the right-of-way, data-driven, data privacy policy, and our safety management systems policies and procedures. We do have some research ongoing with Cincinnati, so there's our policy and procedures. I'm not going to go into the details of these, but we do have them. Probably the biggest benefit, or the biggest turn for us, was instead of going from a two-person pilot and bridge inspector operation, which was what we have on the left, we have the bridge inspector on the left and the pilot on the right. And what we found was, and this is very simple, and we overlooked it, I overlooked it, the inspector would tell the pilot, okay, go ahead and fly to cross frame 4. It's bay 3, span 2. And they would look at the inspector and say, what? What's a cross frame? You know, so there was so much of that happening that you'd lose your battery life. You'd have 15 minutes of battery. So that was enough of an obstacle for us to just train a bridge inspector to be a pilot under the Part 107 rules. Instead of the pilot being trained to be a bridge inspector, it was just simpler to go the other way. So once we did that, we found great value. Highly recommend that. Looking at our org chart, we have the unmanned aerial systems on the left, and they service all state agencies. We are down, the bridge world is down at the bottom, structural engineering, and our districts, which is the program, the bulk of the program happens in the districts. So there's 3 players here on our org chart, and the more that you can, I guess, eliminate the communication and work together, the better. So we started doing that with having the bridge inspector be the pilot. A couple of other things, we use Skyward. I highly recommend Skyward. It makes planning the operation very simple. There's a built-in risk assessment. There's about 45, 50 check boxes where you go yes, no, yes, no, yes, no. For example, have you flown within the last 30 days? If the answer is no, you're a higher risk as a pilot. If you know, so we've made all these risk assessments for the pilot to easily plan their operation. Recommend that. And I mentioned that we went from the pilot inspector business model to just the inspector being the pilot business model. There's an onboarding that has to happen. So once somebody passes the Part 107, we know they are legit. We know that they're interested. So then we give them 2 days of training at the UAS Center, and then they have 3 hours minimum using the Phantom 4 Pro, which is a little more of a twitchy, more difficult drone to fly. And then they have 10 hours of solo time, and then they need to record flights every 30 days in order to keep their drone. So far, as of this week, we now have 4 bridge inspectors with their pilot's license, 5 surveyors in the state DOT, 1 engineer, 2 from communications, 1 from construction, 1 from CAD and mapping, and we have 4 pilots servicing the other districts. In conclusion, I have found drones to be more than just a pretty picture. I think if you find a place where you can knit drone usage into your current operation, find something that's working and knit it into that operation, then do so. We are knitting it into our snooper operation, as I mentioned, and I don't get paid by Skydio, but once we got the Skydio 2s, I knew we found the right drone, and we used that for bridge inspection to get in close, tight corners. Lastly, my contact there is in the bottom left, and Dave's contact is in the bottom right. He's with our UAS Center. He's more in-depth with the policy procedures on the UAS specific information, and I am in the bridge inspection structural engineering world. With that, I am going to stop my share.
Thank you, Michael. Hey, I have one question for you, and it got upvoted as well from Richard. Is FHWA on board with substituting snooper inspections with UAS inspections?
Yes.
Perfect. And
Yeah.
there's about 4 other questions there for you. If you want to jump in the Q&A box and answer those as we go, feel free. But thank you very much. That was fantastic. And with that, let's go ahead and bring in a poll. Let's see, let me jump to that poll question. We know when you're ready, production. All right, so the question is, in your agency company, whichever is applicable, what ballpark percentage of bridge inspections includes UAS as a supplement to the inspection workflow? 0 to 20, 20 to 40, 40 to 60, 60 to 80, or 80 to 100? We'll give that about a minute for all of you guys to jump in and answer. And production, is that just going to jump back up on screen?
Hey, Ryan, we just want to wait till we have about 65% response.
Got it. Well, I guess when we're doing that, Michael, the other question that we had from Steven, Michael, what are you using to determine crack width length on your signature bridge research with UC?
Great question. I am going to look up the research. I don't know the details of the drone they're using, and I think that was part of the research. How can we make an objective determination from a flying camera what's changed? So I think there's layers upon layers of answers there, and it might be most helpful if I gave the actual research document. So I'll look for that.
Perfect. All right, and it looks like our bridge inspections looks like 0 to 20 with 85% and 20 to 40 with 12%, and then 1% for the rest of them remaining. So very interesting. Well, with that, I'll jump into our next presenter with Collins Engineers and start with Barrett. Barrett is a licensed professional engineer and has 20 years of bridge design and inspection experience. He has designed over 50 bridges and performed over 3,000 bridge inspections. He's a certified diver, Part 107 UAS pilot, rope access technician, non-destructive testing technician, and NHI instructor. Barrett, it's all yours.
Thanks, Ryan, and thanks to Alaska DOT for having me, and thank you for everyone attending. So my presentation is on implementing UAS for bridge inspections, and I'm going to go through kind of a wide range of ways that we can use UAS in for bridge inspections.
Hey, Barrett, can I have your audio is a little muffled, just a little bit closer to your mic?
Oh, okay, sorry. Is that better?
That works.
Okay. So on my cover of the presentation here, I have the Tanana River Bridge, which is about 50 miles south of Fairbanks. So we have used UAS on inspections all over the country, including Alaska. So just some background, we've done over 2,000 bridge inspections with UAS throughout the country. Some of it's been for research. A lot of it, especially recently, has been more for implementation or using it for actual inspections. We are working on, just finishing a phase 4 research report with the Minnesota Department of Transportation. I'm working with Jennifer Wells on that. She actually might be on this call, but that report should be published soon, hopefully within the next couple months. That'll be available. As part of that research effort, MnDOT also got a STIC grant, and they're purchasing drones for deploying throughout the state for bridge inspections. And really the UAS is becoming routine for us, so we're using it on a lot of different inspections in a lot of different capacities. And our inspectors really like to have them with them on the inspection, so it's really becoming a tool that they rely on. And many of you have probably heard, but fairly soon the FAA is going to be allowing flights over people. And I think that's going to be a big game changer, because we will be able to fly over traffic, and that'll open up a lot more bridges that are conducive to using UAS on. So some of the technology, the things we're looking for in an inspection-specific UAS, we like object sensing, autonomous navigation and autonomous flights, the ability to look straight up and to fly underneath bridge decks without GPS. We also want to collect photo, video, and thermal imaging, although photos are by far the thing we want to collect the most. Sometimes we want to do confined space, so as you can see in the image there's a collision tolerant drone, the flyability Elios, which is really specialized for doing those types of inspections. And then in the bottom right, there are targets, and those are propeller arrow point targets, and we use those to geolocate our models so that they're survey quality or close to survey quality. So Mike talked about the Skydio 2, and so did Jesse, and we're using it quite a bit. We really like the obstacle avoidance, and we're also able to get into really tight spaces. It has the 6 4K navigation cameras, so it's using AI to avoid obstacles. And I won't say it's crash proof. We haven't crashed it, and we've put it in some really difficult areas, and it's performed pretty amazingly. Here we're flying between beams of a bridge, and that's very difficult to do with any other drone, with the exception of maybe a collision tolerant drone. So one of the things we did in our research project was we looked at the resolution of different drones from different distances, and just trying to demonstrate how important resolution is. There's no magic. You have to have this many megapixels, but resolution is really important. And you can see the difference in, we have a Skydio and a Nafi and an Intel Falcon 8. And the Intel Falcon 8 has like a high-end Sony DSLR, 42 megapixels. And so, which makes sense, we can see have a lot more resolution in the images, which is important. But the resolution isn't the only thing. So the field of view of the lens, the quality of the lens, shutter speed, aperture, lighting, those things are all really important. And then also the distance you're flying from the object is also very important. So one of the things we can do with the data that we collect, we'll go out to a bridge and we can collect anywhere from a few hundred to thousands and thousands of images of the bridge. We can stitch them into a 3D model, and then that becomes a deliverable for the inspection and a record of the bridge at that time. This is an extra dose bridge we did over the St. Croix River, and this is just a portion of one of the models. But there's like a placard on the bridge, and we can click on any part of the bridge and then see the photos that we take, so it becomes like a 3D photo log. And we can read that sign, so it just shows you the amount of resolution that we can get out of the models and the images. So just some more 3D models that we've done of bridges. This bridge is in Utah, and we processed it in context capture software, and then we're showing it here. We can pull that model right into CAD and work with it in CAD or MicroStation or other CAD software. This is another bridge in Hawaii. So if you've ever driven to the North Shore, this bridge is in Haleiwa. And so you've probably crossed this bridge. It's kind of a notable bridge in Hawaii. This is a model of the bridge in over the Tanana River in Alaska. Just gives you another idea. This is a pretty high up model, but we were able to create a model with the drone images. Another bridge, this is the Tetagooch Bridge, and it's on the North Shore of Minnesota in the state park. And so it almost looks like a picture, but it's a 3D model. So some of the other technology that we're using, and this is pretty out there, futuristic, but it's something we're able to do now. We can do mixed reality inspections using the Microsoft HoloLens 2. So we've been working with Bentley, and we create these 3D models and we can put them into the HoloLens and do like a virtual inspection. So you can do an inspection like you would in the field, but you're in your office, and we can add defects and measurements and all those things right in the HoloLens. This is what it looks like if you're wearing the HoloLens, and so you're seeing a holographic version of the bridge. It doesn't give you this, the video doesn't really do it justice, but you can see how it works. We have these little menus that float up in the air, and we use our hands to navigate the menus, and we can navigate the bridge. We can move around, we can teleport to different areas of the bridge, and then we can add our defects and elements. And this is specifically being built for bridge inspection, so it's not just a software that we're adapting to bridge inspections, and we will be able to take the data from these virtual or mixed reality inspections and import it directly into our bridge database as elements, quantities, and conditions, and those kinds of things. One of the other important things that we're able to use now is using artificial intelligence to find cracks, specifically in concrete. And this software that I'm showing here is by Fujifilm, and we fly the bridge. The software stitches all the images together, and we're able to create a model, and then the artificial intelligence finds all the cracks in the deck, and we can download all those cracks into a spreadsheet and quantify them and classify them. So it's a pretty powerful way to analyze your deck. And if you've ever measured cracks in the field, it's very difficult to do it because there's traffic. It's not always safe, or you'd have to do traffic control. And just measuring cracks in the field is difficult because they're very irregular, and trying to measure them with a tape measure can be difficult. And deck surveys are probably one of the easiest and best ways to implement drones. So if you're looking for a place to start, this is a great way to do it. It's pretty easy. The decks are arguably the most important element on the bridge to maintain, and a deck survey can really help with that. And then if we create a full 3D model of the bridge, we can look at the decks, the cracks on the top, and then correlate them with cracks on the bottom, which can be really helpful. Just another example of artificial intelligence. This one is the Context Capture Insights by Bentley. And again, we're finding cracks automatically. And with any of the artificial intelligence, it's not always completely accurate, but it's very easy to go in and delete marks that maybe really aren't cracks, and kind of fine tune it in the office and then get really accurate results. We can use infrared, as Mike mentioned. It is difficult to rely on it, but it is a tool that we can use and is available on a lot of drones. So when we create these 3D models, I mean, they're cool, but they really do serve a purpose. And one of the purposes is to be able to extract element and defect information out of them. The models are dimensionally very accurate, usually sub-centimeter quality, so we can measure all of our defects and our elements, and then import that information into our bridge inspection database or report. So the next thing I'm going to do is talk about a case study and kind of try to tie everything together on how we use UAS. In this case, we're using it for a bridge rehabilitation project. And this is the Stone Arch Bridge, which is located downtown Minneapolis. It's a 22-span masonry arch bridge. It used to be a railroad bridge for James J. Hill, but now it's a pedestrian bridge. And we're currently kind of in the middle of a rehab project for the bridge. And the workflow for using UAS on a rehab project, the first thing we do is we go out in the field, we collect the data on the bridge, which is mainly in the form of images and ground control points. We create a digital twin or a reality model of the bridge. In this case, we're using context capture. We do a field inspection, and we are using the model as part of the field inspection. I'll talk about that in a little bit. And then we can also use the modeling as the part of the design and plan preparation. And eventually, we will also supply the contractor with the model so that they can use it for their purposes as well. So the first thing we do is we plan our flight missions. In this case, we're using the Intel drone and Intel mission control software. We pull in a previous model of the bridge, and then we plan everything in 3 dimensions. And I can't remember how many flights we have, but you know, the whole thing consists of, I think, probably 7,042 megapixel images. It took us about 3 days to collect all this. So, but it's a lot of data to collect, and you collect it really quickly in the field. And this is what it looks like when the drone is flying in the field and collecting the images. It does just like a lawnmower pattern. It's all autonomous, so the only thing we really need to do is take off, push play, and it collects the images. It'll collect almost 400 images per set of batteries. And then we take all those images and those ground control points that we collected, and we process them into a reality model or a digital twin. And this is what a small portion of the bridge looks like. It's all tiled, so the closer or the more you zoom in, the more detail you get on the bridge. And our inspectors in the field had tablets. They had access to these models through ProjectWise on the cloud. And so instead of using pencil and paper to record all the defects and deficiencies, they recorded them directly on the model. And so the benefit is that, you know, all you have to do is worry about what your actual inspection notes are, and you don't have to worry about locating those defects, which is really difficult to do as if you've done a lot of inspection, like locating cracks and stones can be really challenging to do it accurately, and this takes that out of the equation. And then we can import it into CAD and manipulate it that way. We can pull those inspection notes right into CAD and then start preparing either our inspection reports or our repair plans. And one unique thing about this project is that the Army Corps of Engineers drew the river down. This is the Mississippi River, and there's a lot just upstream and downstream. They drew the river down to inspect their own facilities. So we took advantage of that to refly that portion of the bridge and collect data, because we wanted to capture the portions of the bridge that are normally underwater. And we were able to do that, and you can see it became a little bit of a tourist attraction too, to be able to walk out onto the riverbed. And this is what the model looks like after we've flown it. And you can see all the portions that are normally underwater. And if we zoom in, you can see the amount of detail we get in these models. It almost looks like a picture, but that's actually the 3D model. We can see the exposed rebar, and we can measure it, and we always can reference the actual photos that are tied to this as well. So that's all I have. I appreciate everybody's time, and I also included Jennifer Wells's contact information. She's been working with us on the MnDOT research and is a good resource as well.
Barrett, I do have one question for you, and then there is one in there for you to answer as well. But is the resolution of the 3D model good enough to pull accurate dimensions for member size, thickness, bolt spacing, etc., if you needed or basically for repair plans?
Yes, it is very accurate. It's you know, it can be on the millimeter level, which is which is plenty accurate for our purposes. And that's kind of hard for people to believe, but it really does. We can get that kind of accuracy out of it.
Excellent, thank you.
Hey, Barrett, we have a couple other questions that popped in. Let's see if we can get to those real quick. Can you please let me know the type of segmentation or object instance used for the automatic identification of cracks? It appears the bridge joint was falsely identified as a crack. Based on your experience, do you have any suggestion in preventing false positives from happening?
Well, yeah, that's a good question. I think for now, until artificial intelligence becomes perfect, and I'm not sure that it ever will, our method is just to go through the models and look for false positives and delete that information manually. And it'll keep improving, and hopefully we get to the point where we don't have to do that. But it really only takes a small amount of time to delete those false cracks, and then we can make it more accurate.
Sure, cool. Can you also talk in detail about how you get so much detail in your capture models? Most that I've seen have been greeny in comparison.
Yeah, that's a good question. The answer is that there's a little bit of an art to it, but the biggest factor is we fly very close to the bridge. We take very high resolution photos, and so that helps a lot. Context capture and I don't want to endorse any one thing over the other, but we've had very good luck with getting really clean models out of context capture, and so we've kind of gravitated towards that. And the other thing is the models are very accurate, but we can also reference those photos too. So if we see something in the model, we're not quite sure if it's that clear, we can pull up the model or the photos very easily and use them as well.
Sure, cool. And I have my own question, I guess. Can you talk about the learning curve for generating these 3D models in the software? Is that a specialty? You have one person that does that, or can most anyone on your team do that?
Most everyone on our team is doing that now. There is a little bit of a learning curve, but it's really not too difficult. And once you start using it, it's amazing how often you end up doing it. Like we're doing a project where we're imaging all of these inside of these box girders. So we have a photorealistic model of hundreds of individual boxes for MnDOT, and that's it's relatively easy. There's some tips and stuff that we could give people to kind of help them get off on the right foot. But it's there's a lot of people in our company that are using it now.
Great. Well, that's exciting. Well, thank you very much, Barrett. We'd like to move forward with our presenter from Utah DOT, Jara Eric. He graduated from the University of Wyoming in 2009 with civil engineering degree. He started his career in the private sector in the construction and mining industry before starting at UDOT. At UDOT, he has worked on 3D bridge design and currently is the structure inspection manager for in-service inspections. He also served on the UAS UDOT implementation committee and is a licensed UAS pilot. So, Jara, the floor is yours.
Awesome. Thanks. Good morning, good afternoon, everyone, depending where you're at. First off, I'd like to thank Ryan, Jesse, and the rest of the team at Alaska DOT to put this together. I think it's really awesome that we're able to get together and talk specifically about bridge inspection and UAS, and hopefully take ideas from one another and really kind of try to improve the whole system. I think all of us are still pretty early on in the learning curve, and I'm trying to figure out the best ways to implement all of this. So with that, I'm gonna go ahead and share my screen here. So hopefully you guys are able to see that. As I get going here, one thing that I think has been mentioned previously, and I'm sure will be mentioned before, while we're talking about using UAS as bridge inspections, it's definitely just a tool to supplement our inspections. By no means are we replacing actual inspectors in any situations. So I think that's a pretty important thing to note, even though we all know it as well. As we move on, I've got a quick outline of what I'm hoping to cover here really quick. Do a quick overview of kind of what we have in Utah structures and kind of the challenges we're facing and what we're hoping to use UAS to accomplish. A quick look of what UAS systems we're using and also kind of what we're looking for in a UAS system. Dive into the inspection side of things for certain areas of the bridges and how we're trying to implement that into our inspection policies. Hopefully have time to touch really quick on infrared cameras and what we're trying there, and then just have a quick summary and what we're trying to go to next. So just a quick overview of Utah. For those of you that haven't been here before, I've got a map off to the right-hand side there. Overall, we have just over 3,000, and I think 40 bridges is the last count that I have. That's local and state owned. Our structures group is based in Salt Lake, which is that star towards the northern part of the state there. We are sent, even though it shows the regions there, on the structures side of things, we are centrally located, and our group in Salt Lake here is responsible for all of the state and local inspections throughout the whole state. Something else I wanted to touch on real quick. Many probably know we're pretty famous for our snow, but we do have a lot of different terrains. Up in the northern part, we do have a lot of mountains and valleys. And then just the further south you get, we move into high mountain deserts and more of the flat and arid terrain. And overall, Utah is actually quite arid. We're one of the drier states in the country. And the reason I want to bring that up is that for better or worse, that kind of results in us having less signature bridges. We have a lot of the cookie cutter 3 to 5 span steel or pre-stressed concrete beams. And so one of the things that I'm really trying to focus on in this presentation is how do we use that in those structures as well? As has been mentioned in previous presentations here, there's definitely great use for them in those complex structures and signature structures. I don't want to downplay that at all, but I do want to kind of dive into the other area as well. Starting off with a quick timeline of kind of where we've been at with UAS technology and bridge inspection. The department as a whole, right around 2010, started some research with our Utah State University with fixed drones. The feeling right around then was the technology wasn't quite there. Fast forward to 2016, and then I think we were all seeing those large strides in UAS technology. And at that point, the department as a whole decided to form a committee on where to implement it, how to implement it, and what's going to be the best way to do that. And luckily for us, bridge inspection was included in that committee right from the get-go. And also the department purchased our first UAS systems, 2 of which we have used on bridge inspections. Going up to 2018, we started to map decks after manual sounding. I'll dive into that a little bit later, but we found that is a really good way to get started, I believe, as Barrett mentioned earlier. And we also implemented the beginning of our UAS policy, more just to acknowledge that it's a really good tool, not really to say which instances it should be used in. In 2009, we had our first internal bridge inspection staff, and the actual inspectors certified to be UAS licensed. We're still working to get everyone through it, and I'm sure everyone's had their own struggles with 2020, and it kind of delayed a few things, but hopefully by mid this year, we hope to have all of our bridge inspectors also licensed as pilots. And also we were able to get out with each of our inspection teams. We have 2 in-house and 3 consultants that inspection teams that we use for the most part, and kind of do raise the comfort level with the UAS with each of the teams, kind of see where can it be used and where do we think we can fit it best into our practices. And then 2020 to now, like I mentioned, the challenges of 2020 kind of delayed our rollout a little bit from where we want. We're still definitely in the rollout phase here, but we did update our policy to include instances where we want to start flying decks and mapping decks, because we do think that provides a lot of good information. And then as the new FAA rule comes out that lets us come fly over traffic, I agree with Barrett, that's going to be a huge plus for us with a lot of these inspections. And we're really focusing on getting that whole UAS as a tool program going. Next, I'd like to talk briefly about at least what we in our group look at for UAS systems. One quick caveat is it really depends on what you're going to fly. Some of these are going to be important sometimes, some of them are not. And I'm sure there's certain cases where there's other things that are going to be more important too. So really focus on what you're going to fly and kind of gain what you need for your UAS system from there. Really quickly going through them all. We try to get cameras with at least 20 megapixels. If you're going to get real close and next to it, megapixels isn't quite as important. But kind of like what's been hinted at earlier, sometimes you just can't get close, like with bridge decks, mapping those if we're still keeping them open to traffic. Your ground sampling distance really comes into play. Megapixel isn't what solely guarantees that. It's your distance and your sensor size and a whole bunch of different things. Most UAS systems will calculate the ground sampling distance. But hopefully we're hoping for a ground sampling distance right around of that 0.012 inches so we can start hitting those entry-level condition state 2 cracks. And as we get to some AI discussions later, that's also really important, because if you don't have that ground sampling distance that small, the AI I don't think is going to be able to detect what you would like it to detect sometimes. Cameras that look up, and the lighting is also really important. Obviously, we're getting under bridges in a lot of these cases. You need to be able to look up, and how are you going to see what's there if it's too dark? Better infrared cameras really give you better results is what we're finding. How does it fly in the wind? I'm sure every UAS pilots that's flown near a bridge will agree that the wind profile will try to pull you into the bridge. And if it handles well in the wind, or even just flying in general, there's a lot of areas out there that have a lot of constant wind. And while it is up to the pilot to make sure that they can fly responsibly there, having a UAS that helps you meet your goals without it being a perfect weather day is really important. Flying without GPS, so anytime we fly under a bridge, obviously we're not going to have GPS unless it's a really quick strafing run. While most drones can fly without GPS, it is a lot harder to fly in tight quarters. It's a lot less stable. I know the Skydio has been mentioned a lot, and some drones like the Skydio out there do have some really awesome technology that can help you with that. But it is another consideration to make. And then lastly, cost. Obviously, we do need to spend our taxpayer money wisely and be able to justify the costs. And that kind of leads us to a conversation we've kind of had internally in our group. Would we rather have one drone that kind of checks all those boxes, that's a jack of all trades, or maybe a few smaller specialized drones that we can have in our toolbox for our bridge inspectors to go out and decide which one they want to use for that specific bridge to get what they need to? The UAS systems that we're currently using are listed there. We started out with the SensaFly Albris, which is in the photo there. And also with the DJI Phantom 3. The Albris was one of the really first ones I think that focused on the inspection side. It's got a lot of cool sensors on it. It is a little bit harder to fly. That's one that is really kind of hard to get into tight situations, and it can catch the wind a little bit. So there is that. You see a lot of DJIs on there, and that is a lot because when our inspectors try them out, they feel really comfortable flying them. They're really easy to fly. And while I don't really want to promote any one brand, I really do want to throw out there, as you're looking at different UAS systems, really get the chance to demo them out and make sure your inspectors are comfortable flying them so that they can get to the spots they need to see everything. So we do have kind of a lower end Mavic 2 for our general inspections, and then we have the Matrice that is more of a specialized interchangeable cameras, a camera with a lot of zoom for our special inspections. And then some of the drones our consultants are using is the Paradinafi, the caged Elios that you saw in the earlier presentation, and also the Intel Falcon. And again, it's not about emphasizing any of these drones specifically. It's really about focusing on what you need for your goals. So looking into the actual bridge inspections themselves, I know when I first started thinking about UAS bridge inspection, the superstructure and the high structure components are really kind of what came to mind for me, to help you get to those spots where you just can't visually without either an under bridge inspection crane or rope access or some other sort of special access that can be, I mean, you have to take traffic controls, cause a slowdown for the traveling public and safety concerns. So using drones for certain situations like that, I think is really a great idea. A great example is this bridge that you can see on the slide here. So on that lower middle picture there kind of gives you a general overview. This is on Interstate I-84 just east of Ogden, Utah. It's kind of leading into a canyon going off to your left, and you can see that the hillside is getting right up next to the bridge, towards the south side of the bridge there. And we also have a river that kind of ducks in under the bridge, runs under it, and then ducks back out. And also this bridge is wide enough that our snooper truck, if we deploy from the north side, we just can't quite reach the south side. So while it is possible to deploy from the south side, it is really a headache to get into and takes a long time to get everywhere we need to. We selected it to try it out with UAS, and as you can see in the right picture there, we were able to get over the river next to the hillside there and kind of get a good look at some of the deterioration on the beam ends, that delamination / pending spall on the top of the pier cap. And we were able to look at each of those pier caps and really get a good look at the beam ends, and even under the bridge over the water, kind of getting a good look at the pier caps and all the bearings. So this, I think, was a really good example of, it's not necessarily a signature bridge, but it is a really good spot where UAS excels. Another area that we found that it helps us is helping us document changes in the channel for scour evaluations. We had one bridge where we were losing significant amounts of embankment around an abutment due to a flash flood and the stream slowly trying to change course. And we were able to use UAS to document upstream and downstream a little ways to give to our hydraulic engineers so they could help determine what was the right mitigation to stabilize the channel and in turn stabilize our bridge. Kind of diving into the policy side of things for our bridge inspection specific only, I should mention that UDOT does have an overlapping UAS policy that pretty much does follow the Part 107 guidelines and some of the notification stuff that we require, and making sure that all of the information archived through the drones is tracked and all that fun stuff. But diving into the bridge specific stuff, this is kind of one of the first policies that we implemented, just kind of acknowledging it as a tool that we could use. So pretty much what we're saying is, really, if you're more than 35 to 40 feet away from a superstructure or substructure element, you need to use some sort of tool to see that, whether it's the underbridge inspection crane or something else. We did say that you could use a UAS in some of those situations, providing you meet some of these further criteria. Right now, we've been limiting it to all NBI ratings of 5 or greater. So pretty much if we're saying if it's a poor rated bridge, we still want to get hands-on to make sure we're getting everything documented that way. And right now, as was mentioned before, FHWA requires hands-on inspections for fracture critical bridges, so we don't allow that as well. I will mention a little bit later, I think there maybe are a few areas that we can work with our FHWA counterparts to get a few of them inspected maybe with drones, but we'll see where the data leads us, I guess, on that. And then also something else that we added, we also have quite a few bridges that we also put the under bridge inspection crane on, not nearly as much as was mentioned before in the other states. But most of them that aren't really fracture critical, we have on more of a cycle, like every 3 cycles or every 2 cycles, depending on the risk factor and redundancy of the bridge. And we did put in there that if it's still in overall good condition and we're using UAS to get up and look closely at a lot of these areas and we're not seeing anything significant, that we can maybe extend that cycle out of using the under bridge inspection crane less to limit the impact on the traveling public and again, the safety of our inspectors. Next up, kind of dive into the deck. I know Barrett said that this is a great place to start, and I have to say I agree fully. It really wasn't somewhere we were focusing on when we first started our research, looking into how this is going, but it is something that definitely popped up. Again, increasing safety, and also increasing data quality at the same time, we feel. I think it's a pretty big ask for our inspectors to go out there in some of these high ADT routes that has like 5 or 6 lanes of travel. You're trying to document all these defects out there in those lanes of travel while trying to keep an eye on traffic. And obviously getting traffic control in some of these areas is really hard, if not almost impossible to do, unless there's a significant thing we need to go out there and look at. The ability to be able to, in this case, throw a drone up in the shoulder and get a really clear view to map it all together. And it's probably a little hard to see, and I apologize for that, but also using our software, we're able to mark out, in this case, as patches, and over here we have some defects. And it also gives us a rough square footage that gives us a lot better data quality of us trying to estimate it in the shoulder. And also something that has also come about that we've noted is anytime we go out and do manual sounding, and we do have lanes closed for that, we found that it's just a whole lot easier to put a UAS up in the air and map all of our sounded areas instead of trying to go through and manually locate each of those areas and get that data to our CAD specialist to get into AutoCAD. We've cut out about half of our labor and traffic control time just by putting up the UAS in the air and mapping it in less than 30 minutes pretty much. And we also find that the data quality there is a lot better. We don't have patches overlapping here and there, and it's just easier for everyone in general, it seems. So going into the policy side of things a little bit, for the deck specifically, this is a pretty new change we made in our policy, but we do give the option now for inspectors to stay off the deck in certain situations. Like if there's more than 3 lanes of travel, if there's narrow shoulders, we vary it depending on the speed. And then if there's a high ADT, again, just to focus on the safety, and we feel like we have the opportunity to get really better quality data as well. Also, we're asking our inspection team to map any bridge deck with an NBI 5 rating or less. This is really to try to get information to our planning and design engineers with the hope of, if we can get 2 cycles side by side and maybe even 3 cycles, we can really map out where are the changes and deterioration happening, how fast is it happening, hopefully get an idea of when we need a rehab project or whatever project's coming next. And then even kind of our goal is kind of to even expand that maybe even a little bit further, even on some of our good condition decks, to hopefully, again, get that side-by-side comparison and really help us on our deterioration modeling and get a good idea of how fast are our decks deteriorating and where are they deteriorating, and all of that information. And again, it's all better data going back into our inspection report. A quick overview of the inspection workflow that we're in the process of rolling out. First off, the team lead or assigned designee reviews their assigned bridges for if a UAS is a possible tool. Before they're out at the bridge site, they do need to obtain internal UDOT approval and other approval from other shareholders as needed. I do want to kind of speak on that real quick. It's really important to have good shareholder communication. One of the deck examples on the slides earlier is actually right at the base of a runway for Hill Air Force Base, a military base in Ogden, Utah. And it's kind of one of those bridges that you would think there's no way they'd ever let us fly there. I mean, they have F-35s coming in and out of there all the time. But luckily, we have such a good relationship with all of our local major airports and minor airports that we've been able to find times to fly bridges like that. We've actually flown that bridge multiple times because we've been doing a research project on that. So really good communication with your shareholders does enable you to do a lot of flights that you might think wouldn't work. So once they're out on the site, the pilot should do some sort of pre-flight check, an area safety check, make sure they're not going to run into any light poles or utilities and that it's just safe to proceed. Then they go into actually performing the UAS inspection. One part of our policy does require the bridge inspector to review either real time or right after all of the footage, just to make sure there isn't something we need to follow up immediately on, either with another UAS flight or if we need to get lanes closed and whatnot. And then following up, if we're mapping, we're giving the option for our inspectors to upload their photos straight to the cloud to process and get that stitched together photo of the deck. And then kind of tying it all back together to get that data in a usable format to upload the photos to our bridge folder, our bridge record, I should say, in the report, and then update the quantities as needed if they see something that needs to be updated in those photos. Touching real quick on thermal cameras. I know it's been mentioned a few cases earlier already. So thermal cameras, I know a lot of states out there are already using thermal with vehicle mounted or even handheld, and it's really the same science behind it, just with thermal. I would mention that we found having more high-end thermal cameras really gives you a better result, it seems like. The lower cameras, we can't really see as much unless it's right at the perfect time. The higher ones that we can see more. Off on the picture to the right, this is a bridge deck in downtown Salt Lake that they were doing rehab over here to the left on. So we took the opportunity to fly it. You can see up here that you can actually see the beams and the bays through, which is pretty cool. And then there are these few hot spots, and that's actually one of our inspectors out there verifying if it's a DLAM, and we did find a DLAM there. And it's actually one that I'm not sure we'd find sounding, just because the change in sound from being on top of the beam to the bay was also playing with it. So it is really hard to interpret, but I do think it can tell you something, but it is also not a silver bullet in all cases. So doing a quick summary of what we've seen so far. Once again, deck mapping we think is a good place to start. We're leaning towards having multiple specialized UAS systems instead of one jack of all trades that covers all the areas we need. And it kind of also ties into the next bullet point that was mentioned previously. The inspectors are definitely aware of how expensive the UAS system is, and they're definitely more hesitant to fly the more expensive ones for fear of crashing them. As they get used to it and more comfortable with it, that does go down, but there is that in the back of their minds all the time. We do think we're having the opportunity to increase safety and data quality. One important thing to note as you're trying to go in and plan it, and that we're still working on and trying to get better on, is plan where you're going to store all the extra data and photos, and how are you going to tie that and getting that data into a useful format for your engineers later. It's a lot of data. We're using the Google Cloud right now to store a lot of it, but it is a lot of data, a lot of photos, a lot of videos. And then we have an internal approval process that we've gone through and kind of streamlined for bridge inspections, which has been helpful. Near-term goals, again, flying over traffic with the new FAA ruling is going to be huge for bridge inspection. It's really going to help us out. Using machine learning to identify cracks and spalls. I think that's real. This is kind of a similar photo that was in the previous presentation, again from Collins. They're one of our consultants. I think it still has a little way to go to training, but I think it has a lot of long-term. It's going to really help us out once we do get it trained. And then using UAS on tunnels, possibly, and maybe on the fracture critical cables. I think there might be a spot for that. And I'm running out of time, so I'm going to kind of just skip to the end here. I'm sorry I went through a lot of things pretty quick, but feel free to shoot me an email if there's more questions that we can't get to later, or of course, put them down in the bottom, and I'll be happy to answer whatever I can.
Jerry, we do have one question before break from Michael. What type of infrared camera are you using? Is it the Zenmuse XT2 for the M210 series?
Yes, that is the camera. So we do have an infrared camera on the Alvarez, but the one that attaches to the 210 series Matrice is the one that we're having a little bit better luck with, it seems like. And again, a lot of it is based on interpretation, and we still have a long ways to go to make sure we're seeing what we think we're seeing, but that is the one so far we've been using.
So having better success with the 640 and the higher resolution thermal Are you finding any benefit in scanning before and after sunset with thermal loading, or not much difference between it?
I think we do gain some benefit from that. In fact, with the Albris, that's where it has a little bit weaker resolution in the infrared camera. And that's where we really kind of saw the most indications, was right with sunrise or as the sun was leaving the bridge. So I think it helps see it, but we did notice with the more powerful infrared camera, it's definitely extending that time of when we can see useful data, I believe.
Perfect. Well, Jared, I thank you much for presenting, and we're going to go ahead and jump into our 10-minute break here, so everyone can get coffeed back up and join us back here for our next presenters. So we'll see you in 10 minutes.
Hello, everyone. Welcome back. Our 10-minute break is over, and we are going to begin the presentation back again with a poll question as we transition people back into our webinar. So if production can launch our questions, that'd be great. So we have a couple here. Question number one, regarding inspection personnel hours required per bridge, UAS implementation has blank the number of man hours physically spent on the bridge. Has it increased the number of man hours or decreased? Obviously, not all of us have implemented drone use for our bridge inspections, but we can probably take an educated guess here. And I don't think increasing is necessarily a bad thing if we're getting better value out of it. So just curious what your experiences are. And question two is similar regarding inspection personnel hours required per the UAS implementation. I'm talking about now man hours post-processing, so report generation back in the office. We're obviously collecting more data, more pictures, images, possibly 3D, video. Do you think your report generation has increased or decreased time after the fact? And we'll hold on question three for a little bit. We'll let those populate because question number three requires some photos for production to bring up. So maybe they can go ahead and bring those up right now so that we can see those as I read aloud question number three. So we've been, us bridge inspectors have been in these NHI courses before, so I get to play NHI course instructor here. With these photos that you see, assuming you're inspecting a multiple span structure crossing swift but clear water, do you think a drone-based observation would give you enough information to sufficiently inspect substructure elements, so your abutments and piers to mudline, sort of elongating or canceling the need to perform an underwater inspection with a diver? So if you're not able to physically get there to probe for safety reasons, but the water's clear enough and you can take images from above, does that help alleviate that? You can check the box, if you will. Love to see your answers. So please populate those in, and when we have enough, production will give us the results. And while we're waiting, I do see that we have a couple of questions in our box from Ryan and Michael. Because of we're a little bit behind schedule, but and I think that's fine. We have lots of content that's being shared. I think we have a question and answer session at the very end with all panelists, and perhaps we can move those to that point to get those answered. So great. So we have our results. Looks like the vast majority think it's decreasing time at the bridge, which is great, but there is increased time needed in the office. And a decent split here between whether drones will allow you to check the box. Maybe later on in the question and answer session, we can put Pete on the spot and see what his interpretation is. I'd love to hear that. So thank you, and I'll hand it off to Ryan now, who can introduce our next presenter.
Hey, thanks, Jesse. Up next, we have Michael Baker International. We have Alicia McConnell. She's been leading the UAS program at Michael Baker International since 2018. She oversees 31 pilots across the nation that perform UAS-based missions, including survey and mapping, bridge inspections, communication tower inspections, construction and monitoring, disaster assessment, building facade inspection, roof inspections and thermal analysis. She's also a certified Part 107 UAS pilot with significant experience in bridge inspections. She, since beginning to investigate using UAS for bridge inspection in 2016, she has performed over 100 UAS missions across the nation. Alicia is joined by co-presenter John Zuliger, who is the rope access inspection team manager at Michael Baker, with a background in civil engineering, emphasizing structural and geotechnical skills. His academic training and projects have been conducted in the area of earthquake engineering, structural health monitoring, finite element modeling, and fracture critical and fatigue analysis of bridges. And with that, I'll hand it off to you guys.
All right, thanks everybody. Thanks for having us, and thanks everybody for attending that has called in or popped in on the internet. Here, let me share my screen. There we go. Can everybody see my screen?
We can.
Great. All right. So we just did some introductions. So I'll go ahead and skip past that. So at Michael Baker, we did our first bridge inspection in 2016, and that was with Wisconsin DOT. We did a series of 3 of their bridges, really kicked off our program and started that learning curve where, you know, we have greatly improved since then, but we learned a lot from that, and they did too. We started off with 6 pilots. We now have 37 across the country. Bridge inspections are more difficult flying, and it takes a lot more training. So right now we have 4 that perform bridge inspections. 2020 we were supposed to have more, but as we know what happened in 2020, we couldn't really move around much and get some of that hands-on training done. Due to all the different types of flying that we do, we have 34 UAS in our fleet now, and since 2016 we've been incorporating UAS into every bridge inspection that we possibly can. This is just the inspection portion of our fleet. We have some specific airframes for mapping. The Falcon 8 is really good for mapping and modeling type of missions. But what you see on the screen here is kind of what we'll use on a regular basis. I don't have the Phantom 4 shown. I ran out of room, but that's an easy one to fly as well. And it's really versatile. So sometimes our inspectors will grab one of those and go. But we've got the Inspire 2, Falcon 8, Skydio 2, we just got some of those, the Matrice 300, that's new to our fleet as well, and the Anafi Thermal. You can see some of those features that go along with each of those. We usually like the higher resolution cameras. I broke the mold on getting some Skydios because you can get so close, but sometimes whenever you can't get really close up, maybe because you can't do that sustained flight over traffic, that's where an Inspire 2 with a zoom lens or the Falcon 8 really come in handy. One thing I did want to cover quickly was just the overall kind of program safety. You know, whenever we first started at Michael Baker, we started our program, we didn't have a lot of this stuff established. And as we started to get more and more pilots, we noticed that, you know, to keep consistency across the company and across the nation with all of our pilots, we needed some guidelines, standard operating procedures for them to operate by. And consistency out in the field, make sure everybody has the equipment they need when they go out. Everybody starts off as an inexperienced pilot. So our chief pilot conducts our training, so we make sure everybody's trained in the same way. We have checklists when you go out to the field. And I think Jara covered this in his workflow. Mine's shown a little bit differently, but that FAA compliance report there, that's what you fill out. So it's our documentation that we're mitigating risks before we go out on site. And we have looked at that location to make sure it's not in controlled airspace. There's not, you know, overhead power lines and trees, and it's going to be not conducive for an inspection. So all of those things we've been developing over the years, and they continue to develop as we learn more and more. I had this slide at the end and decided to kick it up here to the front. Lessons learned. The panelists and I were all talking beforehand, and we talked about the difference between our first time flying for bridge inspection and now, and what all the things that you've learned. Take it slow. Whenever you're out there, you get better data whenever you fly slow. We've flown them fast and we've flown them slow, and slower is usually better. Whenever we go out on bridge inspections, we're usually out there all day, mainly, for a lot of our bigger inspections for complex structures, we're out there for 4 days. So, and we need to be able to operate all day. Battery maintenance and battery management is really key. In between every single flight, we plug everything in. Our tablets run low, so if you smart charge them, you can just plug everything in. It doesn't matter if you're down on the ground for 10 minutes, plug it in. Downloading data between each flight, that was a lesson learned from one of our pilots. If you happen to lose an airframe in the water and you're not going to be able to recover it, you better not have 8 hours worth of data on it, because then you lost a full day instead of 20 minutes. So make sure you're checking all your data in between. You can have an unfocused camera, you can have a smudge on the lens, you can maybe need to refly something because the exposure wasn't right. So this is all part of our policies and procedures from lessons learned. And we make sure our pilots do that each and every time they put it on the ground to change batteries. Keeping tablets warm in the cold and cool in the heat, that's important for us too. Sometimes we've had them go black. It doesn't change the operation of the airframe. It just is a little nerve-wracking. So all good things to remember. The next 2 slides here. During some client meetings, we've had really great discussion in the meeting, and then I've been asked multiple times what's it actually like in the field. When people are starting to implement UAS for bridge inspections, it's like, well, how do you actually do it when you're out in the field? Well, this is how. Our chief pilot took a picture of this before one of our inspections, and I ended up marking it up for a client and saying, this is essentially how we lay out our vehicle. We've got charged batteries on one side, we've got a charging station set up on the other. The inverter is run out to the front of the vehicle, hooked up directly to the battery. Between every flight, we set our controllers down on the bottom right there, plug them in. We've got extra cones. We usually have a backup airframe with us. In this case, we have 2, the Phantom and another Inspire 2 with us for this one. We've got a computer for offloading data, extra cords, everything you need. And then this is another one. This is a lesson learned here. You can see there's a chalk line on the screen here. We oftentimes run into magnetic interference whenever we're out on a structure with certain airframes that we use. And if you have railings, metal railings or anything like that, you'll get a compass error, and you don't want a compass error when you're flying, because then the UAS becomes confused and unpredictable, which we don't like. So if you find a good spot, mark it out, take off and land from there. Like I said, we've got the inverter on the front. It's kind of tucked in behind our pilot there, but yeah, that's kind of how we set up our vehicles. And I know we've been talking, a lot of the other presentations are talking about deliverables and what we're actually collecting while we're out there. Currently, what you have to perform or what you have to deliver to the client has to go into the inspection report. That's where we're at. So every photo or video you take, you have to be able to take a representative image and put that in the report. As backup data, we use video for all of our inspections, and then we have full coverage, full documentation. So if we come across something, the next inspection cycle, we could go back and look at that if we needed to. And we can deliver that on external hard drives, things like that. People aren't really, or most clients aren't really set up to handle models right now. So we use those internally and for our larger structures. Some of the smaller routine stuff, we're not going to model that, just use it as a tool in the toolbox for those inspectors out on site. Out in the future, I know we've seen a lot of these models and AI and things like that. It's definitely out there. We're headed that direction. It would be so great if everybody could have a model of every bridge and just zoom in and out and see all the different defects, but the infrastructure isn't there to host that yet. Right now we're on inspection reports, but I look forward to the day that we can use some of that more advanced technology. From here, I'll hand it over to John Zuliger to talk about some project examples and case studies that we've had over the past few years.
Thanks, Alicia. Can you hear me okay, guys? All right.
Yes, we can.
Great. So as Alicia mentioned, there's a lot of advantages to having this tool in the toolbox, and being on the rope access team, climbing is pretty arduous for a full day, week. That adds up. So this has been really helpful for us. And as others have mentioned, at the heart of our nation's infrastructure, there's a lot of girder bridges. I think we looked at NBIS data for 617,000 bridges, and almost 70% was girders and slabs. And, the complex bridges really require some effort, and the time difference, may be a trade-off. But one of the projects we wanted to highlight was this Lindcamp Creek Bridge, where there were known cracks, whether they were fractures or fatigue. Some were growing and some had cracked all the way through. But the Kentucky Transportation Cabinet wanted to monitor these without implementing the snooper every quarter. And that would also minimize the MOT on an interstate bridge. And so we came up with a solution of using the Inspire 2 to scan under the bridge and look up into the girders at the constraint-induced fracture locations you can see in the bottom right. So, really advantageous to keep an asset like a snooper, a state snooper, allocated for other NBIS inspections. This was just monitoring. So it made sense to get out there with UAS. You can see the terrain that would be required to get across there. And then also rope access on girder bridges is pretty tough to do. Next slide. So in this case study video, picture here, the William Natcher Bridge, we initially intended to repel every cable. It had not been done before, but we also were going to scan about 25% with UAS, do a case study, a validation study, and then the script got flipped where the winds picked up. It was about 40 miles per hour, and on rope, vertically, not such a big deal. You get blown around a bit, but when you're sliding down a cable and you have several hundred feet of rope out, it turns into a big sail and can actually lift you back up the cable. Pretty impressive. So what we ended up doing was discussing again with the cabinet, when the weather clears, use the UAS. We had already repelled about 25–30% of the cables at that point. And then if the UAS discovers something, we'll go in for a closer look. And then, of course, out of 96 cables, we found one major deficiency. So we were able to hook up ropes and go down and give it the lick test to make sure it wasn't rust versus grease. And, big difference if strands had been popping in there versus, grease leaking out. And that's what it turned out to be. So further investigation could occur from there. And it was another great example where, these are mostly just sheathings that you see on the outside. You don't see the structural components, in UAS. Proved itself very useful. Next slide. And this was a great collaboration with ODOT District 9, where previous cycles had involved repelling cables. I think it took about 9 or 10 days, which is pretty consistent, like what we saw on Natcher there. Excuse me, thank you. But we also did Harsha in 2019, right. And so with this one, it was a great example to be able to scan all of the cables 100% while the snooper was doing the underside fracture critical work. And then we had another small rope access team for anything else we needed to pick up along the way. So we cut this down from almost 9 days to 4 days with the UAS. And again, that man at risk hour savings is really beneficial. And then you get full documentation of all of this data for the, the life cycle analysis and health monitoring of the bridge over time, which we found really, really helpful when you're considering making maintenance decisions. Next slide. This was a little bit of a different one. It wasn't quite an NBIS inspection, but a rehab project where initially we considered 14 to 15 days of climbing on the bridge. We needed to look at fatigue-prone details to be retrofitted, but mainly we needed to look at the gusset plates for cable replacement on the Sherman-Minton Bridge. And that was able to be cut down almost by 60%, I believe, where we were able to do this in 6 or 7 days versus the 14 to 15 days, because all we needed to assess was, are the gussets in good enough condition to be able to, reattach to. And with the UAS, we could get underneath of it. The Inspire 2 was able to look up under the members, and now, with additional UAS, probably do this a little differently, but it kept us off the roadway. And with the larger size of the Inspire 2, we were able to see this across the entirety of the bridge. Now we did fly from both sides, at times, but we, again, could fly across the whole thing without even having to move locations and maintain visual line of sight the entire time. So next slide. This is just an example of how we've been using this in load ratings. Outside of just inspections, it's really powerful for when you don't have plans available. This allows you, to get all of your measurements on a gusset plate, your Whitmore sections. Is the section loss, effective in that area? This has been really powerful for us, where we don't have to spend time in a lift or on rope in the cold. This inspection here was 20 degrees out, I think. So, really, really helpful. But somebody still has to get down there, measure a known scale, so the UAS can pull that off of, or when you go to measure the data later, that can be assessed. And the section loss, things behind the plates that it can't see, like on a truss, we're going to still have to measure that, but it significantly cuts down the time you're measuring, bolt spacings and overall geometries of elements like this. Next slide. This was a project in Utah where high-level scans, again, many have talked about deck scanning. The cracking was mapped on this bridge, multi-girder bridge, similar to like we did on Natcher in 2017, where, with the cable stay, really important to know what's underneath the bridge for the floor beam system, same here. And then infrared was done as well, just to, again, kind of test that. I know FHWA has more guidance for using infrared technologies. Others have talked about that as well. We found mixed results, but it is another tool in the toolbox to consider. Alicia, was there anything else you wanted to add to this one?
Not specifically. This video in particular, we were a little late in the day. We needed to get the other mapping done, and it was a little too warm already. So, but like you said, another tool in the toolbox, and in the right atmospheric conditions, hopefully we get some good results.
And for this, back up to Alaska here, our inspectors were doing some oil and gas bridges, and they needed to get out there with rope access, but also, to access in that method, you have to use beam clamps and aid climbing, and it gets really tedious. So they were also able to use UAS to get the outside of the girders to kind of help cut down some of that work, get up in between, really another efficiency tool, and able to perform this in very cold climates. This next bridge actually, it was a pre-stress girder bridge affected by the earthquakes recently that I believe were mentioned at the beginning of the conference here. And we had inspectors go out super remote. They were actually passed by dog sledders on the way. So really cool stories that they had from this one, but they went out on snowmobiles. And this isn't one where you want to bring your Inspire 2. So the inspector decided to bring the Parrot, and was able to, basically, it's the size of a lunchbox, put it on the snowmobile, and then the batteries are not much bigger than a cell phone, which could fit in his pockets to stay warm. And we're able to fly, up in between the girders to identify areas where the inspectors would then have to do rope access, which was pretty tedious, again, because these girder bridges don't often allow for, easy attachment or rope work. But at the bottom, you can see the difference where Alicia was talking about the exposures, daytime, really makes a difference. Being able to do that. And that's where sometimes we like to have a two-person system that takes away from some of the workflow of the pilot, so that the inspector can be controlling the camera and get the information that they need, be controlling the exposure, things like that, and kind of guiding the process. So it can be accomplished simply with a single unit, like in this instance where it's a simple bridge. I carry a Skydio now on me too, thanks Alicia. Those have been really helpful to have in the toolbox, but for the bigger operations, it is nice to sometimes have that Inspire 2 or Falcon in the toolkit. Next slide. I'll turn it back over to Alicia to talk about some of our research projects.
All right, so recently we collaborated with PennDOT and did a project for them to determine which UAS would be most suitable for bridge inspections. So we did testing on 6 different airframes, all of the ones that were actually at the beginning of our screen. We have a large fleet, so they thought they'd use it. We actually, before this project, did not have a Skydio and weren't overly familiar with the Anafi. So we ended up calling Skydio, and thankfully they were able to ship us one quickly. So we were able to use it and test it out as part of this project. But we tested it on concrete, steel, showed how, you know, versatile they could be for complex inspections and on connections, cables. And you can see here some of all of that in action. You can imagine being out in the field with 6 airframes between, you know, 1 to 2 vehicles. So there was a lot of battery switching and things like that. But the project went very, very well. So I have a couple of videos here. This was for the night flights. They wanted to see a simulated pier strike emergency response scenario. So on this particular one, you're looking over my shoulder right here. I've got the iPad. I think this is the Phantom 4. And in the far part of the screen there, you can see it illuminated. We used lume cubes. We only tested 3 UAS at night because with the Skydio 2, one of the downsides is if you put lights on it at night, they recommended not to do that because it would actually blind the obstacle avoidance sensors. Same with the Anafi, it wasn't suited for that. So the lume cubes really only fit the DJI products. So we did the Inspire, the Mavic 2, and the Phantom 4 Pro. Down here at the bottom, this is what the UAS recorded. So really great footage, really clear. I feel like if we needed to see something in that emergency scenario, we would be able to here. Also, one item of note, there were fishermen probably 100 feet away at the end of the pier there. All right, one of the other bridges that we did, this was originally where we wanted to start Fort Pitt Bridge, but we ended up splitting it between the 2 locations. So the last half of the week, we were out at the Fort Pitt Bridge. This is where the Skydio actually really started to shine for us. They were doing some rehab on the Neville Island Bridge, and they had a lot of cables and all of that. And obstacle avoidance doesn't work on very, very slender items like power lines and ropes and things like that. So we weren't going to push our luck. I saw one of the questions earlier that if we did the Enterprise edition where you got the software package where you could do a little bit closer flight. Yes, we did. We did that here, and for our purchased UAS or our purchased Skydios, we bought that as well. So this is the case. Popped it up in between the girders, and we're able to spin it around. I don't have a video of that here, but we did a lot of testing in this same area. You can see the bottom right, the table of our UAS. We're actually getting ready for the night flight there. So they're all outfitted with their lume cubes. But we did the same type of testing, cracks on concrete, anything in the steel. And then we also did night flights here. And we tested the same 3. We had a little bit easier takeoff and landing. In these scenarios, you kind of have to make it work. We took off from a construction sign that happened to be downed next to Neville Island Bridge, and we kind of had to hike it to get there. In this case, we had a nice park that let us fly from the sidewalk there. And this video is extremely clear. Again, these are the DJI products, depending on how you feel about those. They got great results for us. I believe this one was the Phantom 4 as well, but very, very clear right along the water line there. I am going to skip ahead so you can see what it looks like up at the top. If there were to be a strike higher up, this was very clear video. I hope that's coming across on your side of the screen. It's not too choppy for you, but okay, good. We had some great results here, and they were very pleased with it. We also had some of the pilots from PennDOT shadow us during all of this, and we got to share a lot of our procedures and things like that with them. And since this was a research project, this is just a snapshot of some of our results. We pulled together a matrix of all the different features of all the different UAS that we tested, operating ranges, everything that you could think of, some of those intangibles. You know, how does a pilot feel about flying it? Is it portable? You know, or do you have a giant case that you have to carry around, or can you throw it over your shoulder? And then our testing matrix results as well. So, you know, that's where those megapixels come into play. As at high resolution, you know, you need to be close, yes, but if you can't be close, then what UAS may be best for you. So we gave them a couple of different scenarios based on all of the testing that we did. And then kind of to wrap it up here, you know, we talk about, you know, group exchanges like this, peer exchanges like this, and how we can advance the industry so more and more people are comfortable using this technology. like I said, we use it every chance we get. We incorporate it into those workflows because we now have the experience to understand where we're going to get reliable results and where it's not the right fit. You know, with Connecticut DOT, we had an opportunity with them to do some high mast light inspections and contribute to writing their standard operating procedures for those out into the future. It was a great experience for us and them. Alaska DOT, we had some UAS projects with them out in the northern region. Did quite a few flights out there, and you know, we're trying to expand and share some of our experience there. With ODOT, the e-learning courses, they've gotten great reviews. We just shared some of our experience as far as what we try to see in pilot, or what we look for in pilots, and what type of tasks you'll be doing. One of the previous presentations mentioned it's a lot easier to train an inspector to be a pilot than a pilot to be an inspector. So have a good skill set, a good base skill set, then learn to fly. And then, you know, we're probably going to be interested in you joining our force. So again, use case studies and research that we're trying to push the envelope here. With WISDOT, Kentucky Transportation Cabinet, they've been very open to bridge inspection case studies. And with PennDOT, they're starting to push the envelope as well. So I've got a lot of good stuff coming out, and people are continuing to learn and do some of these projects. And then out into the future, I know Barrett touched on some of this, you know, as far as what we see out into the future of what will become of bridge inspections next. I don't think you're going to replace an inspector in the very near future, or probably ever, but you know, people are pushing for autonomous flights. Let's get rid of some of the risk associated with flying. If you've ever flown around a bridge, you know what it's like with wind and things like that. So this makes a lot of people nervous. But people are really trying to incorporate autonomy into these types of missions to, you know, make them faster, make them more efficient. In order for that to happen, those, you know, there's going to have to continue to be improvements in sensors and those detection methods. At what point are we confident in the AI detection? You know, some of that conversation earlier was about, you could see on the screen that the AI was calling out pretty much anything and everything. And I know John has some opinions about that as a longtime inspector, about like the alarm fatigue. If you call everything out, you're not going to pay attention to any of it. So what's meaningful to an inspector? So John, you want to jump in on this?
Sure. I guess just real quick, you know, as far as the collection methods, you know, talking about girder bridges versus complex bridges, you know, the geometry is actually sometimes trickier on the girder bridges, even though they might be like they seem like a simpler bridge, where we can shoot across with zoom lenses, get, you know, cable insides and things like that, and do different things with the UAS. I think the autonomous paths will definitely help improve some of this in the future. But, you know, what is the trade-off between just going out and flying it by stick and then, you know, building these models to then allow it to fly autonomously? And then, like Alicia said, the detection is a really great thing. I think anything that can help us flag would be great. But just as long as it's kind of responsible in what it's flagging, because we don't want to get, you know, like she said, alarm fatigue and start, you know, not paying attention to things. So I think that's all I have there.
Yeah. And if anybody has any questions, feel free. We do have a couple of case study videos here out on YouTube. If you want to look at some of them that we've done, it just kind of highlights things that we found, some of our operations. And we also prepared a video for PennDOT. We can hopefully get approval to share, but it kind of shares a little peek behind the curtain of what it actually takes to get out there for a bridge inspection. So hopefully we can show you guys some of that later on. Feel free to reach out.
This has been great. Thanks, thanks, Alicia and John. In an effort to sort of catch back up on time, how about if we sort of hold off on the question that you got, Alicia, and we'll put that to the very end when we have the whole thing. Although I do want to say that I appreciate your image of the back of your van. I screenshotted that for my future use, so thank you for that.
I can go ahead and send that to you too.
Okay, perfect. So our next presenter is with the University of Alaska Fairbanks. Dr. Jessica Cherry is a hydroclimatologist. That's fancy. Specializing in airborne and satellite remote sensing. She served as a research faculty member at the University of Alaska Fairbanks from 2006 to 2016, and now splits time between the National Weather Service and consulting through UAF and Northern Science Services, LLC in Anchorage. Dr. Cherry holds an FAA commercial pilot certificate in single engine land and sea, multi-engine land, and remote pilot systems. She owns a Science Cessna 182 based out of Merrill Field in Anchorage. So Dr. Jessica, the floor is yours.
Thanks, Jesse. All right, can you see my screen okay?
Yes, I can.
Great. Well, thanks everybody. This has been super interesting. So since I'm a geoscientist, I've been learning a lot about bridges during this, this workshop. It's been really great. I'm going to talk a little bit about a project here that's been funded for a couple years now by Alaska DOT. And we'll combine some UAS work with some work done from crewed aircraft and GoPros on selfie sticks. And we're going to focus on the wintertime story because the motivation for the project was really to study the interaction between river ice and bridge structures themselves. And because I'm a geoscientist, I don't necessarily know all the bridge vocabulary, so bear with me there if you would. Okay. So acknowledgements again, thanks to Alaska DOT. The UAS portion of this project started in 2019. Thanks to Tim Smith, was a contractor through UAF who did a number of our UAS acquisitions. And again, I'm going to show some results from a crewed airborne project that took place from 2016 until last year. And thanks to Mike Knapp down in Juneau for support of this work here. So the objectives of our project were to use UAS to collect imagery around bridges and culverts that are prone to what we call off ice and groundwater buildup during winter, to better understand that ice bridge interaction, to test inexpensive commercial off-the-shelf systems during Alaska's cold season, and then compare alternative technologies such as fixed and portable field cameras and crewed aircraft, and then to use that imagery and experience to generate training material for Alaska DOT, and that's still a work in progress here. So what do we know about ice and bridge structures? In my work with NOAA, I am a hydrologic forecaster, and our big impactful season in Alaska is during river breakup. And a lot of what's out there in the peer-reviewed literature about ice and breakup and forecasting ice jams really focuses on this kind of what's shown in this simple cartoon, which is during the breakup period, you get some signature processes that you can usually see from air and increasingly even high resolution satellites. But you get these hinge cracks on the side, you get transverse cracks across the ice sheets. And then in this case where you have a bridge with some piers that go into the river and the submerged land, that the chance for damage has to do with the breakup of these surface sheets of ice and scouring and ridging against the bridge structure. We think there's some other things going on, and that's sort of not a lot of information in the published literature, and something that can be pretty impactful in Alaska. So here's a photo from this pretty big event in 2015, where in March on the North Slope, some groundwater from the Sagavanuktuk River flooded the Dalton Highway. And this is the only access point on land to the Prudhoe Bay oil fields. This was an extremely expensive event in terms of damage it caused to the road, as well as to blocking road access to the oil fields for, I think it was a couple of weeks. This is a groundwater process in what should have been, the dead of winter. There is not superficial melting at this season, and so this is in the far north of Alaska, but a process that we don't know very much about. What is off ice? This is sort of a picture from a paper by Tamlin Pavelski, who partly grew up in Alaska, and this is from the very far northeast of Alaska with some people for scale. So this is a really large scale off ice field where you have groundwater that's forced up onto the ice sheet during winter and freezes and kind of makes these laminations. So it's a sheet-like mass of layered ice that forms. They have different names. Sometimes you hear them called overflow, icings, or naled or naledi in Russian. And again, that's formed by some sort of upwelling of groundwater. Got to move my screen things around here. And it typically forms in the same places from year to year. Question is, structures that block flow of ice and water may help form off ice. And satellite analysis from the far northeast of Alaska has shown that the number and size of very large natural off ice fields has decreased since the year 2000. Another paper here shows the distribution of these, again, kind of in the literature in Alaska has been, the ones that have been studied in detail have been in the Brooks Range in the far north, in this far northeastern corner of Alaska. They're also known to exist in parts of Russia and all over China. So people who are interested in the interaction with infrastructure and who are increasingly building new infrastructure in cold regions should be interested in this work. Not a ton of research out there, but the thinking is, and this is from a study done in northern Canada, that the topography where you have slopes and recharge regions, percolation of groundwater, and then you have the riverbed that is getting forced up and helping drive groundwater base flow through winter, and then the formation of this of these icings. So people have kind of interchangeably used this term off ice and overflow. If you live in Alaska, you're pretty familiar with overflow in the cold regions, which is related, but doesn't necessarily form these laminations, or once it does, you might call that off ice. But other interactions with groundwater and ice in cold weather, as ice thickens, the channel under the ice becomes constricted. And another process that we see in the northern parts of Alaska is the formation of anchor ice and frazzle and things that are in the subsurface that it's ice that's formed, it's sunk, and it gets very sticky. And that sticky ice can actually adhere then to the structures and might be part of what is generating bridge structure, groundwater interaction. And then water pressure may also build, forcing water up through the cracks to the surface in those constricted areas. In warmer weather, there can be a higher rate of water flow as you start to get melt that is going to increase water pressure in narrow channels, and again cause groundwater to push up through cracks and form water on top of the ice and then refreeze. Heavy snowfall can also cause overflow by weighing down the ice, causing it to crack, and again, allowing water to seep through. These descriptions I just pulled out of a nice report that was done as part of a collaboration with traditional ecological knowledge bearers in interior Alaska about changing conditions, again, that are pretty closely related to groundwater upwelling on rivers that are used as roads for travel in Alaska. I'm going to go ahead and skip this one. Okay, so a little bit more before I show you a bunch of pictures and a case study. Again, theory of ice interactions with bridges and culverts have not really focused on groundwater in the past. So there's literature out there about the design loads of ice on bridge piers, a couple different types of loading, static loads generated by thermal expansion or contraction of ice cover and underlying water. Dynamic ice loads that develop when moving ice strikes a pier during breakup. And the way that ice fails as it's breaking up around the bridge, it can be crushed against the piers. It can bend and break on the structure. It can split around the piers. And ice jams can damage bridge piers and abutments through static pressure and dynamic forces, as well as through scour of the sediment. And ice can damage superstructures when you get direct contact, a strike, or through vibration. Bridge piers can initiate ice jams and delay breakup in some cases. And of course, on a smaller scale, an ice-clogged culvert is an ice jam during breakup. And future flow regimes may differ from historic empirical data that are used for bridge design. These breakup timing and their nature are changing pretty quickly in Alaska. We don't know very much about groundwater in Alaska. There's very little direct observation. We know we have these sort of different hydrologic regions in the state that are really driven by different climate regions in the state. The case example I'm going to talk about is at the interface of this south central and interior. We also have permafrost, permanently frozen ground, throughout much of the northern part of the state. Again, this area I'm going to mention as a case study is the interface between discontinuous permafrost that has unconsolidated groundwater, and then some more continuous alpine permafrost in the Alaska range. This is the last slide I have on groundwater, but the other factors to consider are, of course, much of Alaska was glaciated. And so we have some sense of where the maximum glacial extents were. This impacts the hydrogeology. And again, there was also this refugium, this area of the state that was not glaciated thoroughly during that period. And even though some of that is alpine. So that all impacts where the groundwater is and how it's interacting with structure. So if I sound like a professor lecturing, I just want to have some background. So to our drone work. So we're using a few different platforms. We started this in 2019, and Skydio are still pretty hard to get a hold of. And so we just chose a Mavic 2 Pro Zoom. And we also went with this smart controller, thinking that that it is a little bit less susceptible to battery draining during cold operations, because it's larger than a phone. It's got its own internal batteries right there, and it's just a heavier, it holds a charge much longer than the phone in our experience. And so that's been interesting. This is just the commercial off-the-shelf Mavic. In the work I do for NOAA, we've been using the government editions of these Mavics, which have much stronger security controls or cybersecurity controls. They're not transmitting data back to the mothership in China or where else. And they're also, they don't have any geofencing. And I don't think that's really been brought up too much today, but if you spend thousands of dollars to get out to someplace and all of a sudden you have this this DGI enforced geofence that's independent from the FAA restrictions, that can be a real pain to get the unlock working if you don't have cell reception, et cetera. So so there are some advantages to the government editions that don't have that, but for this work, we're just using the off-the-shelf one. I'm also going to show some results from the manned aircraft work, and again, this GoPro on the selfie stick approach. So logistics are always a factor, of course, for any kind of field work, but especially in Alaska. So the UAS sites we sampled, which were a couple dozen, I'm just going to talk about one, were on the road system for obvious reasons, much cheaper to get to in winter. But limited light is another logistics concern in Alaska. Limited daytime. The crewed aircraft logistics are a little bit different. We base these flights out of Fairbanks, where we had fuel and in the first couple of years we had some hangar access. And then as we flew these routes, we'd do this whole route within about a day and a half. So one day would be spent going down the Parks Highway, cutting over the Denali Highway, and then over the Richardson Highway, refuel at Gold Canna, and then through these other routes through the mountains. Other logistics, the crewed aircraft with hangar access, we were fine taking off at 30 below on the ground in winter because the aircraft had been warmed. And then once you get up to altitude, there's typically an atmospheric inversion in Alaska. And so air temperatures might be 20 degrees at altitude, even though they're very cold on the ground. So not a big deal. Do I want to fly an uncrewed plane at 30 below? No. So our cutoff temperatures for that were 5 to 10. We did have some problems at 10. Of course, 15 to 20 degrees Fahrenheit is a much safer low point. So now I'm going to go into this case study and just show you some photos. So here, this is the Jack River on the Parks Highway. And this is a picture I took from my Cessna in 2017 in April, so the end of the season. And you can actually visually see that there is off-ice buildup around the piers of this bridge. So that's sort of a smoking gun. You don't see these other buildups around here. So that's a process we want to investigate more. Where is the Jack River? So that is, again, in this Alaska range between Anchorage and Fairbanks. And in this area that's close to what's Broad Pass. It's not very intuitive, but the water actually flows essentially north from here. It's going to join the Nenana River and flow north through the Alaska range, and then it joins up with the Tanana and the Yukon. Here's a satellite image from Google, and wow, this place is a mess. I'm sure the DOT folks could tell me the history of this site, but so the arrow in the previous slide showed the water's flowing from the right screen to the left screen. There's all kinds of impounding of water by the road here, and I'm sure this was used as a material site at some point. But I personally don't know all the history. There's also what looks like some levees or at least some roads or trails that are controlling the metamorphosis of the sediment in this river. And that's just 2017, so right when we were flying. This is a picture from October in 2016 for the purposes of showing the freeze up process. Again, this is from the Cessna, and you see where the channel is. This is early in the Cessna work, so we were kind of figuring out the configuration of the flight maneuvers to get, either closer up of the bridge or a bigger picture of the area around the bridge. Same bridge a month later, but in 2017, it looks like from a bigger point of view that there is, this is a kind of the last part of this area to freeze up is right around the bridge structure. So that's also suggesting you have a deeper channel, and that's really where base flow groundwater is flowing during the winter. Here in March 2018, that season following, you can see that it's fully frozen at this point, and that is normal for the springtime. In addition to generating these orthomosaics, we've also pulled the digital elevation data from that point cloud. We've mostly used Agisoft photoscan to process these. And even in a scene that looks completely white, you do see from the point cloud that is used to generate this digital surface model, subtle changes in the topography of the snow, again, that could give us some clues about what's happening with groundwater. Here's just a focus zoom in there of that. All right, now UAS data is the UAS part of this project that started. Here's just a single frame close-up of one of the structures on this bridge. This is prior to snow melt and prior to breakup, and you can see that the presence of the bridge itself has changed where the snow packs up, or has off ice formed over the winter. This is also from UAS. You can get, I think this is kind of close to that 400-foot maximum, but again, we can generate these orthomosaics from the UAS the same. But of course, the advantage without some exciting flying in the crewed aircraft, we can get it seeing more under the bridge. This is a point cloud from that March data set, showing a bigger picture of kind of the lack of snow deposition under the bridge. All right, here in the last few photos, I'm just going to show then the results from a month later, so April of the end of last year. This is the GoPro. You can see the distortions of that fisheye lens, but you can also see some pretty interesting features, and I just pulled out a couple of these shots, but you're seeing actual holes in the ice where groundwater is actively percolating up right at the piers of this bridge, kind of as the ice is ripening. Here's another view of that. Again, right over the structure, you have ice failing with those cracks, just like we've seen in some of the literature about breakup processes that are dynamic. But then there are also holes in the ice where if I were showing you video, you could see the groundwater is actively percolating up. Is the bridge structure causing that to happen, causing groundwater to upwell? Kind of can look at correlation, but not causation. But I think that's kind of compelling there. Here we go. Here's like get a sense of during breakup, what's driving that right at the pier. All right, I think those are the pictures I wanted to show you today as sort of an intro to our project. Thanks.
Thanks, Dr. Cherry. Appreciate it. And just for time fact, we're going to go ahead and jump into our last presentation with Skydio, Brendan Groves. And I'll do a quick bio. Brendan Groves is the head of the regulatory and policy affairs at Skydio, the largest U.S. drone manufacturer. Hey, Dr. Cherry, I'll have you. Yeah, there we go. The largest U.S. drone manufacturer. and autonomous flight. Brennan works with customers, policymakers, and regulators in the US and international markets to unlock safe and effective autonomous operations. Before joining Skydio, he held a senior position in the federal government, serving most recently as the Associate Deputy Attorney General in the US Department of Justice. In that role, he scaled DOJ's drone program across the country and served on the FAA committee responsible for integrating drones into the national airspace. Brennan is a graduate of Yale Law School and Pepperdine University. All yours, Brennan.
Ryan, thanks very much. Really appreciate the chance to be with you virtually today. I also know I'm holding up the conference now, and we're a bit over, so I'll keep this very short. I don't actually have to talk about Skydio's technology because quite unexpectedly, lots of other people have done that. I didn't know that was going to happen today. So I'll focus really on automation and regulation, how we can as a community, regardless of what platform you're using, push the envelope, break the boundaries, make drones much more useful, and increase worker safety, which is something core to our mission and a goal shared by many of our colleagues in the industry. So we all know, gathered today, just what promise drones have offered. We've discussed some of the realization of that promise. AASHTO in 2019 did what I think is the seminal study that showcased the risk. Half the cost using half the amount of people for the prototypical freeway bridge inspection. This is something we've seen at Skydio. At Skydio, we had a lot of organic traction among the bridge inspection community, not just here, but actually increasingly around the world. And we've now started to focus on serving this market because we really see the positive environmental impact, the positive benefits to worker safety, and of course, ROI and efficiency. The issue is, for many programs that we talk to every day, that has seemed like a pipe dream for two reasons. One is technology, one is regulation. We've talked about the limits here today already of technology. Good luck flying a drone that requires GPS under a bridge. Not going to go well. Good luck taking off next to metal struts and railings. If your drone does not like electromagnetic interference, I hope that works out for you. It's not going to. We obviously have the benefit of producing products that don't need GPS and that are not subject to EMI, and that has turned out to have lots of benefits in this very unique and very important inspection context. But the regulatory front, which is really the barrier that people are now beginning to run headlong into, and that's the fact that to inspect below the bridge deck, typically, but not always, you're standing on the deck. You can't see the drone. That means you need a waiver. It hasn't been easy to get that. And even if you did get it, and there have been fewer than 70 beyond visual line of sight waivers ever granted by the FAA out of more than 3,000 applications, even if you did get it, more than likely you would have been required to use visual observers, to potentially buy a $100,000 radar system, no matter where you're flying. And by the way, you would have been limited to beyond visual line of sight flights in 1 or 2 sites. That doesn't really help. So at Skydio, we've been focused on trying to smash through those barriers, working in lockstep with the FAA. So we're in the middle of this seismic shift. It's a shift that really helps to knock down the doors that we just mentioned on technology and regulation. It's the shift from manually phoned devices to autonomous devices that are sleek and elegant and software defined. It's a lot like the transition from the Nokia flip phone to the Apple iPhone. One is a hardware device. The other is really a software device fashioned into a piece of hardware. At Skydio, we're a software company. We make hardware only to accentuate the software, a lot like Apple, a lot like Tesla. That's really core to who we are. We think that's really the secret to scaling drones. It's really the secret to making them useful in the enterprise context. And when we talk about autonomy, we don't mean what I like to call photonomy, a fake autonomy. Autonomy means you have a device that is thinking for itself, seeing for itself, and making intelligent decisions for itself. That's what Skydio builds. We've been doing this our founders have been working on this technology for about 12 years. They met as grad students at MIT, where they pioneered a lot of the fundamental technology here. I would show you what this looks like in the bridge inspection context, but you've already seen this because our friend Barrett at Collins Engineers already showed this video. It's actually a Collins video. So you've seen the utility of Skydio in the bridge inspection context. So who are we? We're now the largest US drone manufacturer. We actually are really proud to make thousands of Skydio drones a month in the US. And we design, of course, and produce and support all of our products here. And we're also a trusted partner to the Defense Department due to our high levels of cybersecurity and supply chain security. You've heard about today, again, unexpectedly, at least for me, the Skydio 2 on the left there, really our prosumer device, has a lot of enterprise functionality. On the right is the X2. This is the enterprise bigger brother, if you will, older sister. It's more rugged. It flies a little further. As you can see, it has a 12 megapixel camera that, of course, proximity there, and we can get exceptional levels of GSD. We can sort of talk about that, as well as a FLIR Boson 320 thermal camera. It gives a lot of extra functionality, especially in the inspection context. Of course, flies at night, has 35 minutes or so flight time, about a 4-mile range. And importantly, in the world of federal grants, the Skydio X2 is eligible because we are NDAA compliant based on a high level of supply chain security. That's now a requirement, at least for the Department of Defense, and actually for every other federal agency grant, courtesy of this recent executive order, actually, that came down somewhat unexpectedly earlier this month. You've also mentioned or heard mentioned today sort of the software skills that Skydio can add on. Once you have an autonomous platform at the foundational level, you can layer on software as a skill on top of that. One of those is called the Autonomy Enterprise Foundation. I won't discuss this in any level of detail, other than to say that part of the reason we came up with this was after countless conversations with people using Skydios and DJI and other drones to inspect bridges. And we realized that we could, through software, really enable advanced skills like close proximity obstacle avoidance to reduce that bubble around the drone. I should say, Skydios have 6 navigation cameras that see the world in every direction and create a 3D map in real time. It's not some sort of gimmick. It's not a post-processing tool. The drone is always, always, always flying itself. You can manually fly it, but the drone at its core is always flying itself. It knows where it is a lot better than you do as the pilot. It knows where obstacles are a lot better than you do as the pilot. That's really the trick that makes it useful. Of course, the gimbal can go all the way up. That's another feature that we knew we needed after talking in part to the bridge inspection community, as well as the ability you see in the middle to zoom all the way out and see the entire world in every direction. That's a unique feature that we can do because we have 7 cameras, 1 EO front-facing camera, and those 6 navigation cameras that have overlapping 200-degree 4K fisheye cameras around. So one thing we're most excited about, there's been a lot of discussion in this conference about mapping. We are unbelievably excited about mapping, and we're just about to release a new software product called 3D Scan that automates the process of inspecting and building a photogrammetric map of any asset, any structure, including the bridge, without any input from a human pilot and without any knowledge of that structure before you begin the scan. This video that I'm showing doesn't really do it justice. You honestly need to see it to believe it, but the drone uses its computer vision and deep neural networks to map a structure. Literally all the human pilot does is push a button that says take off, and then you select the structure with your fingers, 2 fingers. The drone then goes to town, it conducts an initial scanning route, decides where it needs to take pictures to build a brilliant, beautiful, dependable 3D map. And then it takes all the pictures itself, flying itself in acrobatic Olympic style flying if it needs to, in and out of the structure. I know it was mentioned that some folks have spent 2, 3, 4 days taking the photos necessary to build maps. That's the way this works right now. At Skydio, we can map bridges with 3D scan, oftentimes in 30 minutes to an hour. And when I say we, I mean the drone. The pilot is just standing there watching the operation. That's what the future looks like, but it's not really the future. It's the present. And we've done this before. So last year we released a product called House Scan. It does exactly that for residential roofs. This isn't an R&D project. It's actually the largest commercial drone deal in the history of drones, period, with our partner EagleView. So it's the same product that allows you to autonomously inspect and then use AI on the back end to do change detection on residential roofs. EagleView, our partner, has done more than 1,000 scans using this product all over the United States. Profoundly useful, especially for disaster relief. So again, when we talk about automated photogrammetry, it's not something we just think about. We've actually done that and delivered it. We're also really excited that we're going to release in short order the Skydio Dock. This is a house in which our autonomous drones will live and take off. You could imagine putting this next to a bridge that you know needs special attention. And that way you can inspect the bridge anytime, day or night, using the Skydio X2, for instance. Really a groundbreaking step forward there. There are other drone companies working on docks too, which we think is really exciting, definitely where the industry is going. So now let's just spend a minute or two thinking together about how we can work with the FAA to make these inspections much more efficient. And the way to do that, we think, is to focus on a concept we call close proximity, low altitude operations. People have been focused for years in the industry on flying as high as they can and as far as they can. That's great. Some people need to do that if you're delivering burritos or pizza. But most of us doing industrial inspections, and I'm a former operator who ran a huge nationwide drone program at DOJ, we just need to fly beyond line of sight and behind obstructions. So that concept where you really limit the air risk and you really limit the ground risk is something that the FAA is beginning to accept. But if you're going to do that, you obviously need a tool that is able to fly competently in those tight and confined spaces close to infrastructure. Now at Skydio, we have had some success, a lot of success. Luckily, and really, this is a compliment to our partners and customers to break down some of these doors. So The Verge and others have said, you know, the FAA has these rules, but maybe those rules are written for dumber drones. And that's The Verge saying that, it's not me saying that. And maybe if you have a smarter drone, the FAA is more likely to let you walk through some of those forbidden doors in the past. What we're really happiest about, still proudest about, is a breakthrough waiver that we achieved last year in partnership with the extraordinary team at the North Carolina Department of Transportation. We worked with them for about 5 months to get a first-of-a-kind waiver that allows Skydio drones to be used to autonomously inspect beyond visual line of sight bridges across the entire state of North Carolina, as long as they're in uncontrolled airspace. Really an extraordinary waiver. Again, usually beyond visual line of sight waivers require visual observers. This was the first, or one of the first, that did not require visual observers, in part due to the power of Skydio autonomy. So the FAA trusted that our drone wasn't going to crash into the pylons that uphold the bridge. It's also one of the first statewide waivers. It's not geographically limited. Really astonishing in scope. Here's what it looks like. So if you're the bridge inspector, you can just imagine how happy this makes you, because you can sit comfortably on the deck once it's closed to traffic. I mean, that is part of the regime that the North Carolina and Skydio agreed to, at least in the beginning phase. And you can fly all the way down to the bottom of the bridge, the bottom of the structure, within 50 feet of the bridge and within 1,500 feet of the operator. So really an extraordinarily strong step forward. A lot of safety wins for the operators. They're very happy because they have a lot less trouble. They can actually do multiple inspections, sometimes in a single day. And of course, it makes it easier also if you're looking to insource your drone program, if you do have that regulatory foundation that makes it scalable and safe. We don't have much time to talk about the safety case. Happy to talk about that offline with folks and to work through that. This isn't, a trade secret necessarily. We love to share information and share the lessons that we've learned in trying to be a real leader here. One thing I would leave you with is, if you're going to do this yourself, there are really 3 T's you should think about. Obviously, your technology matters with the FAA, and for these close proximity operations, the more autonomy you have, the better. Training is also really important. Even when you're using an autonomous drone, the FAA is going to want that extra measure of training. And on the tactical front, you should, of course, emphasize infrastructure masking, emphasize that principle that reduces, if not eliminates, air risk, and also probably want to work with a program, be it Skydio or someone else, that has a lot of regulatory expertise, so you get this right and don't spin wheels with the FAA, which is very much easy to do. So with that, again, it's really been a pleasure to be here, to learn from others, and would love to take some questions. Thanks.
Hey, thanks, Brendan. That's been great. I don't see any questions specifically that popped in, but I have a few as you talked. Can you talk a little more about the autonomous 3D scan, and do you as the user have the ability to limit the proximity to like the roadway deck?
Yes, you do.
Yep. Can you talk about that?
Right. So there are two things. So one, the drone always has geofencing on when it's in 3D scan, but you can actually set geofence. You can set it to fly only to the altitude of the bridge deck and not above, and not a millimeter above that. I mean, we did that actually almost specifically for bridges. So from the bridge deck all the way down to the water is an easy setting. This is literally just, like one push of a thumb on your smartphone. This isn't some complicated setting. You can also set the GSD. That's a variable setting on 3D scan going to 0.2 millimeters.
Okay, cool. And your Skydio dock, that's new to me. Are you envisioning that for us, we have remote bridges that we don't have access to or can take hours to get to, but could potentially have a seismic event. And some are
Right.
critical links, like our Yukon River Bridge that has a pipeline that runs across it. Are you envisioning something like that living there and then us deploying after some event and operating remotely? Or would we have to be on site? Obviously,
Yep.
there's some FAA issues there, but what's your vision of that?
No, yeah, you would not have to be on site. So the docks will live there, the drone lives there, but you can fly it from anywhere in the world. And actually, we already have that technology now. We're in the middle of a very advanced regulatory project, which with one of the largest railroads in the United States, based here in the US, and the FAA, to get regulatory approval first for this railroad, and then for other customers, both state DOTs and enterprises, to remotely operate autonomous drones in docks and industrial sites in remote areas first, and then scaling into more densified environments. So no, I mean, the whole point of course, is to have the dock do its job. And then ultimately the human potentially moves from, on the loop to in the loop at the end of the day. So really excited. That's definitely where the entire industry is headed. Great.
Yeah, thank you. I guess right now we'll segue and do a full panelist Q&A. If anybody who's still here, we appreciate it. We ran a little long. We apologize, and I'll let Ryan sort of handle the final Q&A. It's open to all presenters. We can also answer the ones that have been populated before. So Ryan, if you want to take over.
Well, thank you again, Brendan. That was definitely impressive. And I guess we'll start with some of the questions that we have unanswered from the group. It looks like Michael had asked, general question to all, has data storage been an issue, or is the efficiency / benefits of using UAS overall, does it offset the cost to upgrade storage? And I'll open that up for all presenters.
This is Alicia. I can jump in here real quick. The cost of storage is cheap compared to the amount of data that you can get and store for long-term structural health monitoring. So, I mean, you can get cloud-based storage and all of that for a terabyte for, tens of dollars. So it's just finding, researching the storage requirements that you need to follow, and then, expanding that out. So I think that the trade-off is pretty cheap there.
Anybody else to add in on that? All right, well, we'll jump to our next question from Ryan Hill. It looks like, Jara, you had mentioned that you were going to answer this, but Ryan asks, how does the deck mapping work? Does the UAS take photos and then it is the engineer's job to trace and quantify the DLAM locations once back in the office, or does the US system trace and quantify these areas of DLAM itself?
Like I mentioned before, we are kind of early in the rollout process here, but what we're kind of envisioning at this point is the UAS will upload the photos to the cloud would stitch them together, but at that point, the inspector, as needed, would go in and trace the larger defects. I don't think we'll get into the cracking right away, and then be able to get a measurement off that as needed. And then obviously once the AI or machine learning gets to a point where we can reliably trust that it's picking everything up and not getting too many false negatives or false positives, then at that point we would see, I think, the software starting to do it more, and then the inspector would just kind of do a quick review to make sure it's covering all the major spots it needs to.
All Perfect. Thank you, Jarrett. Looks like Anna, you have a question for me. Remember how battery life was an issue out in Bethel? Yes. One of the presenters talked about the cold weather in Ohio needing 2 batteries. Do you see this improving in the near term? Remote locations in Alaska may not have charging options. So yes, battery technology, of course, is greatly improving through LiPo and I believe lithium ferrite or life batteries. But and then of course, as fuel cell technologies come on, other sources of power plants. Of course, for Alaska, yeah, remote locations, we've been really investigating the use of battery stations using the I'm going blank on the name. The Goal Zero battery stations that we use as the inverters out in the field, since a lot of times we can't carry generators with us, so we bring the battery systems to be able to recharge. So I definitely hope as this, the technology improves during the summer, being able to deploy solar charging options since we have lots of sunlight, and kind of seeing where that technology goes. But yeah, so I think that technology is still expanding, but we'll definitely be on the edge of it, especially for some of the cold environments that we work in. Looks like we got a question for Brendan. Is the Skydio obstacle avoidance hindered at all by low light conditions below some bridge decks?
So the Skydio 2 is meant for daylight operations, but it can work during civil twilight. The Skydio X2 has a thermal camera, so it's not limited by daylight conditions, or it can fly happily at night using the thermal and GPS. So the answer for the X2 is no.
Perfect.
And real quick, I have a question for Skydio. Is there any improvements to the camera anticipated? I know it was kind of across the board. We would like to see improvements to the camera because sometimes we can't be that close to everything. Is that on your radar? So
the short answer is yes. The Skydio X2, brings a 16x zoom on the electro-optical camera and also an 8x zoom on the FLIR boson 320 camera. So there are a lot of improvements there. And then a lot of other stuff that I can't talk about fully here that are on the sort of near term roadmap that I wish I could say. But suffice to say, we've heard a lot of feedback. I mean, of course, the trick is I think most of our customers and partners figure out, like people have discussed today, that you really only need usually for that kind of 3D mapping, massive zoom. If you can't fly close, you can still build beautiful automatic 3D maps with a much smaller megapixel camera flying in closer proximity with AI in the back end. So we've heard that both ways, but we have a lot of stuff sort of under the hood, and the X2 delivers some improvements in that line too.
I have a question for Alicia. You mentioned the Loom Cube earlier, and I think I'd like to know a little more about that. Is that a device that basically attaches to any drone that you have in your fleet, or do you need a specific payload carrying capability?
Yeah, so the Loom Cubes, they have little attachments, just basically brackets that go on, largely for the DJI products. Those are more widespread than most UAS, very common. So they're used in photography originally, but they have a UAS attachment for them, and you just screw them on. They have, the ones we got have like 10 different levels of light intensity. And yeah, you can look them up. It was just kind of an easy thing for us to do out there on our DJI products. But then they also have a strobe for the top. So it's super handy for night flying. You meet your requirements for visibility at night. And down at the Fort Pitt Bridge, we actually needed that because we had helicopters that would oftentimes fly nearby, and we'd make sure we were visible there.
Great.
Yeah.
And I have another question for, I guess, all panel members. When you guys are all performing your inspections, are you all controlling traffic on the bridge, or are you restricting your flight operations parallel to the bridge off to the side underneath. I'd like I guess a little discussion on that with how you're handling live traffic and potentially traffic underneath the bridge as well. Are you just restricting yourself to not get on a vertical zone, horizontal, an imaginary line above the roadway, or what your offset is? I'd like some input on that, please.
I guess I'll start. So for right now, we're just limiting ourselves to not be directly above any traffic, just staying in the shoulders and getting whatever we can. And then, like I mentioned, the new rule upcoming should really help out to be able to get over there, over traffic.
Yeah, I'll just jump in and say you have to have a pretty wide bridge before you start to run into problems with not being able to get good coverage of the whole deck operating from the shoulders.
I'll echo that too. Typically, even if you're up 100 feet, you can see across it unless you have something that's really, really wide. And then you can either go a little higher if your camera is high enough resolution, or yeah, just be offset. So, and I mean, my interpretation of the new rule is we're not going to be able to do sustained flight over traffic or people anyway. It's more of that passing over. I don't know if anybody else has a different interpretation, but that's kind of what it sounds like. So it's not like we're going to be, just hovering above traffic and taking pictures or video. We're still going to have to be off the side, but if we need to pass over, we can.
Cool, thanks. I guess I'll answer this, or I'll ask this question. Barrett and Alicia, BIM is more widely used for buildings rather than transportation infrastructure. Have you seen many bridge owners integrating the UAS modeling capabilities with BIM for signature structures?
Yeah, we definitely are starting to, and I think as the architecture world is farther ahead of us in the 3D space, but like the example I gave of the Stonearch Bridge, I mean, we definitely are integrating the 3D models throughout the entire process. And it's amazing how we have a project-wise team and we have maybe 25 team members, and almost every day somebody asks for access to the model to be able to do their specific job. And it varies. It can be hydraulics. We've even had the endangered species people want access to the models. And so very quickly, those models become a really important part of the project. But the technology is there to do it. We're just, it's just not that widespread in transportation yet.
Great, thanks. One other question just populated towards Skydio in regards to the attachments. Can the Skydio 2 accommodate attachments such as additional lighting and propeller guards?
So the Skydio 2 is really, because of the autonomy system, it's not meant to be modular. It's really meant to be an integrated solution. So that's the sort of the short and sweet answer with the Skydio 2. There are some additional options there we can discuss, but it's really meant to be an integrated package offering.
Okay, thanks. Ryan, I think I stole the Q&A you were supposed to be emceeing for the panelists, but I can hand it back over to you if you have any more questions or if you want to do your closing remarks.
Yeah, I think the last question I have, and maybe not just a question, but I noticed there was quite a bit of, and something that we've been doing a lot of research on is the ground sampling distance, our survey control, especially with a lot of us using structure from motion and LiDAR technologies. But and this is something that Peter kind of mentioned, is this something that as a group we should be putting forward our basic imagery standards for, say, AI detection? I think it was Jera or maybe Barrett that mentioned the 0.012 inches for adequate AI detection, but is this something that maybe all of us should put forward as a white paper as far as all of our imagery specs for, hey, if you need structure for motion, here's the basic item. I saw a lot of with Michael Baker's presentation with camera sensors, but yeah, going from there, is this something that we should pursue further with a working group of imagery standards as far as data deliverables with the UAS integration?
I guess just a quick comment on that. I'm always going to say more data is always good to let us know what we can accomplish. And I do think machines learning is new enough that we are still kind of learning what those limitations are. I don't think there are any hard rules yet, but definitely more peer exchanges and whatnot. Transfer of data is always probably going to be a good thing for the industry as a whole, I have to imagine.
Absolutely. Well, I guess with no more questions, I'll go ahead and close everything up. Thank you guys for jumping over. I think we definitely packed a lot into our peer exchange, and look forward to chatting with you all more and sharing all of our work from here on out. And with that, thank you for joining us here today. And as we start to develop and build this program, we definitely look forward to being a part of your guys's data as well as sharing what we find here as we move forward. So, Jesse, anything to add?
No, just welcome. We're glad we were able to welcome everyone to this. We didn't intend on having this national broadcast, but I looked at the panelists in here, or the attendees, and it looks like we had a widespread from all over the country. So feel free, my contact info, you may have it. It was on my presentation. You can email me, and when the link becomes available, this will be an available webinar that can be viewed online or downloaded. I'm not quite sure how that's going to work out, but when it does, if you email me, I will forward that to you all. So yeah, once again, thank you all to all attendees and presenters. It's been great. We've learned a lot.
Thank you, everyone.